Hey everyone, and a very warm welcome to Planet Time. This is a quiet little corner of the internet where we can get comfortable, take a deep breath, and explore the incredible wonders of our planet and the universe that holds it, all in a calm and soothing way. I am so glad you are here. We are about to start a journey together, a thought experiment that's both a little chilling and profoundly beautiful. It begins with a simple, almost childlike question. What if, one day, with no warning at all, the sun just vanished? Not exploded, not burned out over billions of years, but was just gone. Instantly. Before we fall down that rabbit hole, I have a little question for you. I wonder what the weather is like where you are right now. Is it a bright, clear day? Or is it already dark, with the moon and streetlights painting the world in a different kind of light? Whatever you are up to at this very moment, whether you are starting your day or winding down for the night, just take a second to notice the light around you. We are so used to it, aren't we? It's the most reliable thing in our lives. Have you ever been at home in the evening when the power suddenly goes out? For a split second, there's that deep, surprising silence, and a darkness that feels much heavier than ordinary night. Your brain takes a moment to catch up. You find yourself standing still, waiting for your eyes to adjust, every little sound suddenly amplified. It's a strange, disorienting feeling. Now, imagine that feeling but for the entire world all at once, and forever. That's the journey we are about to take. And if you find these kinds of questions as fascinating as I do, maybe you can help this video out. A simple thumbs up or a kind comment helps our sleepy little signal find its way to other people who might be wondering about this too. It is a quiet way to let us know you are listening, and we appreciate it more than you know. So, let's begin. Find a comfortable spot, maybe grab a cup of tea, and let your curiosity guide you. We are going to turn off our star and see what happens next. Introduction. The 8-minute loan. Imagine a perfectly normal Tuesday afternoon. You're walking outside, feeling the familiar warmth on your skin. Birds are singing, traffic is humming along, everything is exactly as it should be. And then, 93 million miles away, the sun simply ceases to exist. It is plucked out of the universe, as if it were never there. But here on Earth, you do not notice a thing. You continue your walk. The sky is still a brilliant blue. The warmth on your face is still there. For the next 8.5 minutes, we are living on borrowed time, blissfully unaware that we are now orbiting a ghost. You see, light, as fast as it is, doesn't travel instantaneously. It's the universe's ultimate speed limit, but it is still a limit. The last rays of sunlight that left the sun right before it vanished are still on their way to us, like a final postcard sent from a long-gone traveler. It's like watching a live broadcast from a distant star. Even if the star explodes, you'll still see its light for a while, because the news of its death hasn't reached you yet. And then, it happens. One moment, light. The next, a profound and complete darkness falls over the entire daytime half of the planet. But the light isn't the only thing that's been traveling for 8.5 minutes. So has gravity. We tend to think of gravity as a mysterious force, a sort of invisible rope tethering Earth to the sun. But Einstein gave us a much more beautiful picture. He told us that massive objects, like the sun, literally warp and bend the fabric of the universe, what he called space-time. It's like placing a heavy bowling ball on a stretched-out rubber sheet. The ball creates a dip, a curve in the sheet. Earth is like a marble rolling around the edge of that dip. We are not being pulled. We are following the curve. When the sun vanishes, the bowling ball is lifted from the rubber sheet. The fabric of space-time, which had been curved by the sun's immense mass, snaps back to being flat. That ripple, the news that the sun's gravity is gone, also travels at the speed of light. So, At the exact same moment the world is plunged into darkness, the gravitational tether breaks. Earth, no longer held in its cosmic dance, does what any object in motion does. It flies off in a perfectly straight line, a newly orphaned planet careening into the void at 67.0 miles per hour. Darkness and the feeling of falling into the infinite do not arrive separately. They arrive at the exact same instant. The show goes dark and the stage collapses. Introduction. The long night begins. The immediate aftermath would be a scene of pure primal confusion. For half the world, the day would instantly become night. The sky wouldn't fade to black, it would snap to it. And in that blackness, the stars would blaze with an unfamiliar and terrifying clarity. With the sun's constant glare gone, and no atmosphere scattering light to wash them out, the Milky Way would stretch from horizon to horizon like a splash of celestial paint. It would be the most beautiful sky anyone had ever seen, and the most horrifying. One of the first, most eerie signs for everyone on Earth would be the disappearance of the moon. A few seconds after the main lights go out, the moon would simply wink out of existence. We forget that it is not a source of light, it is just a giant dusty mirror reflecting the sun. With no sun to shine, the mirror goes dark. The planets we know and love, Venus, Mars, Jupiter, they too would vanish from our sky, one by one, as the last of the sun's old light finishes its journey to them and reflects back to our eyes. Odds. Panic and chaos would surely grip humanity, but as the hours and days wore on, a much more fundamental problem would take hold. Earth is like a baked potato you've just taken out of the oven. It is hot at first, but it immediately starts losing its warmth to the cold kitchen around it. Our planet is constantly radiating heat away into the freezing vacuum of space. The sun is the oven, constantly providing the energy to keep us warm. When the oven is turned off, the cooling begins. How fast would it get cold? The first week, the average global surface temperature would plummet below freezing, to about 32 degrees Fahrenheit. By the end of the first year, it would drop to a devastating minus 150 degrees. Plants, the foundation of nearly all life on Earth, would die within weeks. Photosynthesis, the magical process of turning sunlight into energy, would stop. The great engine of life on our planet would grind to a halt. The oceans would begin to freeze over, starting with a thick crust of ice on the surface. Within a year, the surface of our world would be a frozen, silent wasteland. The long night has truly begun. Introduction. Echoes of the Wolf. This scenario, which we can describe with the cool language of physics and thermodynamics, touches on something much older and deeper inside us. The idea of the sun disappearing has always been one of humanity's greatest nightmares. Long before we knew it was a star, we knew it was life. In the ancient Norse myths of Ragnarok, the final world-ending battle of the gods, the prophecy tells of two giant wolves. One wolf, Skull, is destined to forever chase the chariot of the sun, while the other, Hati, chases the moon. Ragnarok begins at the moment they finally succeed. They catch and devour the sun and moon, and the world is plunged into a freezing, starless darkness called the Fimbulwinter. Half a world away, the ancient Egyptians told a similar story every single night. They believed the sun god, Ra, sailed his solar barge across the sky during the day. But every night, he had to pass through the underworld, where he was attacked by his mortal enemy, Apep, a monstrous serpent of chaos. The Egyptians believed their rituals and prayers helped Ra defeat Apep and rise again in the morning. An eclipse was a terrifying moment when it seemed Apep might actually be winning the battle. These weren't just stories, they were explanations. They were our ancestors' ways of grappling with the terrifying fragility of their world. These ancient myths are like the world's first disaster movies, with the sun's disappearance as the ultimate villain. Our modern, scientific, what-if scenario is just the final, permanent version of their deepest, most mythological terror. The wolves have finally caught the sun. Thank you for joining me on this deep dive introduction to our journey. This is the setup, the foundation for our exploration. As we continue, we will go deeper into each of these facets: the survival of humanity, the fate of the planet itself, and the profound lessons that the darkness can teach us about the light. So, let's begin that journey. Let's imagine it is happening right now. Picture a completely ordinary moment. Maybe you are sitting in a park, feeling the gentle warmth of the afternoon sun on your skin. Perhaps you are looking out a window from your office, watching the light catch the edges of the clouds. It's a day like any other. The world is turning, traffic is flowing, and life is proceeding with that quiet, predictable rhythm we all take for granted. The sun is a constant, a given. It is the silent partner in every moment of our lives. And then, 150 million kilometers away, it vanishes. Not in a brilliant, fiery explosion. Not in a slow. There's no warning, no final flare of glory. One moment, there's a star, a colossal furnace of nuclear fusion holding a solar system in its grasp. The next moment, there's nothing. Just an empty point in space. But here on Earth, you do not notice a thing. You take another sip of your coffee. A bird sings on a branch. The gentle warmth on your skin is still there. For you, for all of us, the sun is still hanging in the sky, exactly where it is supposed to be. For a little while longer, our reality is based on a lie. This is the first, and perhaps the strangest, consequence of the sun's disappearance: the delay. Nothing in the universe is truly instantaneous. Every piece of information, every ripple, every ray of light, is bound by a cosmic speed limit. That speed, of course, is the speed of light. It's the fastest thing there is, but space is so incomprehensibly vast that even at that speed, news takes time to travel. The sun is so far away that the light you see isn't the sun as it is right now. It is the sun as it was about 8.5 minutes ago. You are always looking at a memory. Think of it like watching a live news report from a correspondent on the other side of the world. There's that slight, awkward delay between the anchor in the studio, asking a question, and the reporter on screen, beginning to answer. Now, imagine that delay is 8.5 minutes long, and the correspondent is our star. The last photons, the last little packets of sunlight to ever leave the sun, began their journey just before it vanished. And for 8.5 minutes, they travel through the cold, empty void of space on a final, one-way mission to Earth. During that time, we are blissfully, completely unaware of our fate. We continue to orbit, a ghost. We move in a perfect, graceful arc around a point of gravity that no longer exists. Children are playing in schoolyards, farmers are tending their fields, satellites are dutifully pointing their solar panels at a star that has already been erased from the universe. It's a strange and unsettling thought, isn't it? That for a brief period, our entire world would be operating on old information, a postcard from a place that's already gone. We live our lives buffered by this cosmic delay. We see all the stars in the night sky, not as they are, but as they were, years or centuries or even millennia ago. The starlight that reaches us is an echo of the past. But we never think about it with our own star. The sun feels immediate, present. To realize that even its connection to us is on a time delay is to feel, for the first time, the true scale of the space that separates us. So, for 8.5 minutes, the illusion holds. The sky remains blue. The clouds remain bright. The world remains warm. But then, the last of the old light finally arrives. The last photon completes its journey and strikes the Earth. And then, nothing follows it. The change would be breathtakingly sudden. It wouldn't be like a sunset, where the light gracefully fades. It would be like someone flipping a switch on the entire world. One moment, daylight. The next, a blackness more profound than any night you've ever experienced. The source of all our light is simply off. The sky would instantly be filled with stars, blazing with an unfamiliar and terrifying clarity, no longer washed out by the sun's glare. The moon, our constant companion in the night, would also wink out of existence a second or so later, as the last of the sun's light that was bouncing off it completes its trip. It would be one of the first and most eerie signs that this wasn't an eclipse. The mirror has gone dark because the light source is gone. But as shocking as the sudden plunge into darkness would be, it's only half of the story. Light is just one of the messages the sun sends us. The other, far more powerful message is gravity. And the disappearance of gravity is, in many ways, the more profound event. For centuries, we thought of gravity as an invisible rope, a mysterious force that the sun exerted on the planets, instantly pulling them into orbit. If the sun vanished, Isaac Newton believed, that rope would be cut instantly. The planets would fly away at the same moment, with no delay. It seemed logical. But in the early 20th century, a young patent clerk named Albert Einstein offered a completely new, and much stranger, picture of reality. Einstein realized that space and time are not separate things. They are woven together into a single four-dimensional fabric, space-time. And what we call gravity isn't a force that travels gate through this fabric. Gravity is the shape of the fabric itself. Here's the classic analogy, and it's a good one. Imagine a rubber sheet, stretched out tight like a trampoline. Now, place a heavy bowling ball in the center of it. The bowling ball sinks down, creating a deep curve, a well, in the sheet. That's what a massive object like the sun does to the fabric of space-time. It warps it. Now, roll a small marble across the sheet. If it gets close to the bowling ball, it will not travel in a straight line. It will follow the curve created by the ball, rolling around and around in a circle. The marble is orbiting the bowling ball. From the marble's perspective, it is just moving in a straight line, but the very shape of the space it is moving through is curved. That's what the Earth is doing. We are a marble rolling along a curve in space-time created by the sun. This is Einstein's theory of general relativity. It is an idea that completely changed our understanding of the universe. And it carries a profound implication for our thought experiment. If you suddenly lift the bowling ball off the trampoline, what happens? The rubber sheet doesn't snap back into a flat shape instantly. A ripple, a wave of uncurving, travels outwards from the center at a specific speed. Einstein calculated that the speed of this ripple, the speed of gravity, is exactly the same as the speed of light. This was a revolutionary discovery. It means that the news of the sun's disappearance, the information that its gravitational pull is gone, doesn't reach us instantly. That information is also on an 8.5-minute delay. The gravitational message and the final rays of light are, in a sense, traveling in the same cosmic envelope, racing towards Earth together. So, let's go back to that moment. The switch is flipped. The light vanishes. The stars appear. For a few heartbeats, humanity stands in stunned silence, grappling with the sudden, impossible darkness. But while our eyes are adjusting, our planet is still behaving as if nothing has changed. It is still following a curve in space-time, a curve that is at that very moment snapping back to flat. Then, the second message arrives. The ripple of flat space-time reaches us. The invisible well that our planet has been circling for 4.5 billion years vanishes. The cosmic dance is over. What would that feel like? It wouldn't be a sudden jolt or an explosion. It would be more subtle and far stranger. The Earth, which was constantly being pulled inward by the sun's gravity, would suddenly have no force acting upon it. And as Newton's first law of motion tells us, an object in motion stays in motion, in a straight line, unless acted upon by an outside force. The feeling would be one of release. Earth would stop turning a corner and would instead sail onwards, in a perfectly straight line, tangent to the point in its orbit where the sun's influence ended. We would become an orphan planet, flung into the lonely interstellar darkness. You wouldn't suddenly become weightless, floating around like an astronaut. The Earth's own gravity would still hold you firmly to the ground. The sensation would be far more psychological. It would be the dawning realization that our world is no longer anchored to anything. We are no longer in a cosmic home, but adrift in an infinite void. It is the feeling of being in a car that has just hit a patch of ice. For a moment, you are still moving forward, but you can feel, deep in your bones, that the connection to the road is gone. You are no longer driving. You are just skidding. So let's piece it all together. The two events, the darkness and the drift, arrive at the same time, but we would perceive them sequentially. First, the immediate, sensory shock of total darkness. The end of light. Then, the creeping, intellectual horror of the second realization. The invisible tether is cut. We are falling, not towards anything, but just away. Away from the empty space where our sun used to be, and into the vast, unknown expanse of the galaxy. This is the ultimate 1-2 punch, delivered by physics. A knockout blow to our senses, followed by another to our sense of place in the universe. Everything we've ever known, the warmth, the light, the predictable cycle of day and night, the very path our planet takes through space, is predicated on a star that is a fixed distance away. And in this moment, we learn that both the light and the gravity that define our world are not constants. They are messages with a built-in delay. For 80.5 minutes, we were living in the past, orbiting a memory. Now, the past has caught up to us. The light is gone. The anchor is gone. The Earth is a rogue planet, and its 8 billion inhabitants have just been cast out into the great dark ocean between the stars. The 8-minute delay is over, and the long night has just begun. The 8-minute delay is over, and the long night has just begun. For a moment, nothing seems to happen except for the light. If you were standing outside on what was, just a moment ago, a perfectly normal Tuesday afternoon, the first thing you'd notice is the sky. It wouldn't fade. It wouldn't be a sunset. It would be an instantaneous switch. One moment, a familiar, hazy blue. The next, perfect black. It's a blackness deeper than any you've ever seen. And in that blackness, the stars would ignite. Not with a twinkle, but with a fierce, steady, and unfamiliar clarity. With the sun's overwhelming glare gone, the Milky Way would slash across the sky like a brushstroke of divine paint, visible even from the heart of what used to be a brightly lit city. It would be, for a single breathtaking second, the most beautiful thing you have ever seen. And then, the terror would set in. Because this isn't a normal night sky. It's an impossible one. The sun is gone. And then, another impossibility. You'd probably look for the moon, our ancient familiar companion. But it would be gone too. Or perhaps you'd see it for a split second longer, a pale disk against the brilliant stars, and then you'd watch it just wink out. It wouldn't explode. It would simply vanish from sight, as if a switch had been flicked somewhere in the cosmos. It is a chillingly logical consequence. The moon, after all, has no light of its own. It has never been a lamp in our sky. It has only ever been a mirror, reflecting the light of a sun that is no longer there. Its disappearance would be one of the first and most profound signs that our world has been fundamentally broken. The mirror is still there, of course, a silent bowl of rock. But, with the lamp unplugged, it's just another shadow in the dark. For those first few hours, the world would be a place of pure chaos and disbelief. Lights would flicker on in cities, casting a pale, artificial glow against an unnervingly pristine stellar backdrop. Phones would light up, networks would overload. People would spill into the streets, looking up at the sky, trying to make sense of the impossible. But soon, that immediate, frantic panic would give way to a much deeper, colder, and more fundamental problem. A problem that has nothing to do with what we can see, and everything to do with what we can now feel. The cold. You see, the Earth is warm. It's a hot sphere of molten rock wrapped in a thin, life-giving crust. For billions of years, it's been in a perfect equilibrium, like a pot of water on a stove, set to a very low simmer. The sun's energy constantly comes in, and the Earth's own internal heat radiates out. The two forces have been in a delicate balance, keeping our planet in that Goldilocks zone, not too hot, not too cold. But now, the stove has been turned off. The energy coming in has dropped to zero. The energy going out, however, continues. Earth is now like a baked potato you've just taken out of the oven. It's hot inside, but it immediately starts losing that warmth to the cold kitchen around it. Our planet is now radiating its precious heat away into the endless, unforgiving vacuum of space, and there's absolutely nothing coming in to replace it. The great cooling of an entire world has begun. It wouldn't be instantaneous. You wouldn't suddenly freeze solid. The planet has a tremendous amount of thermal inertia, especially in its oceans. The water that covers 2/3 of our world is like a massive, global battery that has been charging up with solar energy for eons. It will take time for that battery to run down. But it will run down. Let's imagine the timeline. In the first week, the change would become undeniable. The global average temperature of our planet, normally a comfortable $15 circa Celsius, or about $59 circa Fahrenheit, would plummet. It would drop below freezing. Below $0 circa Celsius, $32 circa Fahrenheit. Think about what that means. All across the world, in the temperate zones and tropics that have never known a real winter, a frost would begin to form. Rivers, lakes, and reservoirs would start to scum over with a thin, growing layer of ice. For our agriculture, it would be a complete and total apocalypse. Any plant life not adapted for a sudden, deep frost would wither and die almost overnight. It would be the end of the growing season forever. And with the death of the plants comes a much more fundamental death. Photosynthesis, the quiet, miraculous process that forms the absolute base of almost all life on Earth, would stop. Photosynthesis is, in the simplest terms, the act of plants eating sunlight. It's how our world turns light into life. Without that light, the process just ceases. The foundation of the entire global food web would be severed in a single, silent moment. So, within just 1 week, the world is already a freezing, dying planet. The food chain has been broken at its very first link. By week 2, things get much worse. The average temperature would drop to somewhere around -$18 circa Celsius or circa Fahrenheit. Now we are talking about the kind of cold you'd expect in the dead of a Siberian winter, but it is happening everywhere. On the beaches of Brazil, across the plains of Africa, and in the jungles of Southeast Asia. Snow would begin to fall in places that have never seen it. But this wouldn't be the kind of snow we know, born from clouds in a complex weather cycle. It would simply be the remaining moisture in the atmosphere freezing and drifting down. A fine glittering dust of ice settling on everything. And this snow would never, ever melt. The oceans, our great thermal battery, would begin to surrender. A crust of ice, dozens of feet thick, would start to form across the surface of the seas, beginning at the poles and spreading relentlessly towards the equator. This icy shell would expand, locking the waves in place, silencing the shores. The planet would be turning from a vibrant blue marble into a silent white cue ball. It's a chilling thought. In just a matter of weeks, our world transforms. The systems that have governed life for billions of years have not just been disrupted, they've been terminated. The comforting, predictable cycle of day and night, of seasons, of warmth and life, is over. It's been replaced by a single, permanent state of existence, a deep, deepening cold. Now, let's jump forward. Let's look at the Earth after one full year of wandering through the dark. The surface of the planet is now a frozen wasteland, a place more alien and hostile than Antarctica or the peak of Mount Everest. The average temperature has plunged to a staggering -$100 Celsius. That's colder than any naturally occurring temperature ever recorded on Earth. It is about -$150 Fahrenheit. At this temperature, survival on the surface for any complex life form is simply impossible. Everything is frozen solid. The great forests are now collections of brittle, ice-encased statues. The cities are silent tombs, buried under layers of atmospheric frost. The once mighty oceans are now a global sheet of ice, kilometers thick. There is no sound because there is no wind to speak of. There is no weather. There is only the cold. This is the long night. Not just the absence of a day, but the absence of warmth. The great engine of our world has been shut down, and the planet is now just a piece of cosmic debris, quietly shedding the last of its residual heat into the void. It's a sad, lonely state for a world that was once so vibrant and full of life. The journey from a garden to a graveyard has been shockingly swift. And as the physical world freezes over, something else begins to happen. A different kind of cold begins to set in, a cold in the human heart. Because this scientific reality, this terrifying drop in temperature, awakens a much older and more primal fear. A fear that has been buried deep in our mythology and in our DNA since the very first humans looked up at the sun and wondered, what if it didn't come back? It's a question that feels so modern, so rooted in our scientific understanding of physics and space. But the truth is, we are not the first people to stand in the light and be haunted by the thought of its absence. This fear, the deep, gut-level terror of the sun being extinguished, is one of the oldest fears we have. It's a ghost that has followed humanity through the ages, wearing different masks in different cultures, but it's always been there, lurking in the shadows of our imagination. Long before we knew about nuclear fusion and gravitational fields, our ancestors looked up at the same sun we do. But for them, it wasn't a star. It was a god, a chariot, a sacred fire. Its journey across the sky wasn't a matter of celestial mechanics. It was a daily drama, a battle between order and chaos. And its return each morning was never, ever guaranteed. This primal anxiety is carved into the very heart of some of our oldest stories. If you travel north, to the cold lands of the Norse, you'll find the story of Ragnarok, the twilight of the gods. And at the center of that epic end-of-the-world story is a terrifying cosmic chase. For as long as anyone could remember, two colossal wolves had been hunting through the sky. One, named Skull, relentlessly pursued the sun, while the other, Hati, chased the moon. Day after day, the sun and moon would race across the heavens, with the wolves' jaws snapping just behind them. And the prophecy of Ragnarok foretold that one day the chase would end. The wolves would finally catch their prey. Skull would swallow the sun, and Hati would devour the moon, and the world would be plunged into a final, inescapable darkness, and a devastating, world-ending winter called the Fimbulwinter. Think about that for a moment. For the Norse people, the disappearance of the sun wasn't a random accident. It was a violent act, an assassination. It was the ultimate victory of chaos over order, the moment the universe's most sacred promise, the promise of a new day, was finally and irrevocably broken. Our scientific scenario is bloodless and silent, a quiet vanishing act. Theirs was a story of teeth and shadow, of a final, terrible crunch that ends the light forever. It's a powerful and terrifying image, but it shows us something fundamental about the human mind. We have always understood, on some intuitive level, just how fragile our existence is. We've always known that everything we see, everything we feel, everything we are, depends entirely on that light in the sky showing up for work every morning. And this wasn't just a fear that lived in the frozen north. If you travel south, to the warm, fertile banks of the Nile, you'll find the same fear, just wearing a different costume. For the ancient Egyptians, the sun was the supreme god, Ra. Every day, he would sail his magnificent solar barge across the sky, bringing light and life to the world. But every night, his journey would take him through the Duat, the dangerous underworld. And there, waiting for him in the darkness, was his eternal enemy, Apep or Apophis. Apep was not a wolf, but an immense serpent, the embodiment of chaos and oblivion. Every single night, Apep would try to attack Ra's barge and swallow the sun, to stop the dawn from ever arriving. The entire cosmos, in the Egyptian view, was balanced on the outcome of this nightly battle. The prayers, the rituals, the entire structure of their religion was in part a massive spiritual effort to help Ra defeat the serpent and ensure that the sun would rise again. It is a different story, but it's the same fear. The Norse feared a final, apocalyptic end to the sun. The Egyptians feared that the sun might not survive its nightly trial. In both cases, the message is clear. The light is precious, the darkness is a predator, and the struggle between them is the most important story in the universe. Their world wasn't a safe, predictable place. It was a world where the dawn itself had to be earned, night after night. So, what were they really afraid of? Where did these incredible, epic stories come from? Well, these weren't just campfire stories to scare children. They were explanations. They were our ancestors' best attempts to make sense of one of the most terrifying events a person could witness in the ancient world, a solar eclipse. Imagine you are a farmer thousands of years ago. You know nothing of orbital mechanics. All you know is the rhythm of the sun. It rises, it sets. It brings warmth, it grows your crops. It is the most reliable, powerful, and permanent thing in your universe. And then, one afternoon, something goes wrong. A creeping darkness begins to eat away at the edge of the sun. The air grows cold. The birds fall silent. The world, in the middle of the day, begins to look like twilight. And as you watch in horror, the sun itself vanishes, replaced by a black hole in the sky, crowned with a ghostly white fire. What would you think? You wouldn't think, the moon is passing between the earth and the sun. You would think the stories are true. You would think that the wolf has finally caught its prey. You would think the great serpent is swallowing the god of light. You'd believe that the cosmic order was collapsing, right before your very eyes. It would be the most terrifying moment of your life. The world itself would seem to be ending. The panic and terror that would grip a community during an eclipse is hard for us to imagine. People would bang drums, scream, and shout, doing anything they could to scare away the monster that was devouring their sun. And then, after a few minutes of unbearable tension, a sliver of light would return. The monster, it seemed, had been fought off. The sun was saved. The world was saved. For now. So you can see, these legends weren't just myths. They were the science of their day. They were a framework for understanding a universe that often seemed hostile and unpredictable. An eclipse was a terrifying moment when the veil was lifted, showing just how fragile the world really was, confirming their deepest fears that the sun could in fact be defeated. These ancient myths are like the world's first disaster movies, with the sun's disappearance as the ultimate villain. The special effects were all in the imagination, but the feeling of dread was just as real. The monster might have been a wolf or a serpent, but the threat was always the same: the end of light, the triumph of cold, the death of the world. And what's so fascinating is how we, in our modern scientific world, have arrived back at the very same fear, just by a different road. Our ancestors created myths to explain the terrifying possibility of the sun being attacked or consumed. We use physics and cosmology to explore the terrifying possibility of it simply not being there. Our version of the story doesn't have a giant wolf. Our monster is the cold, unforgiving vacuum of space. Our serpent is the law of thermodynamics. The story is different. The language has changed from myth to mathematics, but the core of the horror is identical. It is the terror of the eternal night. In a way, there's something almost comforting about their myths. By giving the darkness a face, a wolf, a snake, they made it something that could be understood, and maybe even fought. You can shout at a wolf. You can perform rituals to weaken a serpent. It gives you a sense of agency, a role to play in the cosmic drama. But what about our scenario? The instantaneous vanishing of the sun. There's no one to fight. There's no one to blame. There are no rituals that can bring it back. It's a quiet, indifferent, and absolute ending. It's the final, permanent version of our ancestors' deepest mythological terror. They feared a temporary interruption to the cosmic order. We are contemplating the erasure of that order altogether. It's a fear that has been with us since the beginning, a question whispered in every language and in every age. It's the recognition that our warm, bright world is just a tiny, fragile island in an endless ocean of cold and dark. The stories we tell about that fear may change, but the fear itself is timeless. It is the echo of the wolf's howl, still audible after all these years, reminding us not to take the daylight for granted. And it forces us to ask a new set of questions. They worried about the cosmic battle. We have to worry about the consequences. Their world would be saved if Ra won the battle. Our world is already adrift. So, beyond the myths and the primal fear, what really happens to us, to our societies, when the great clock in the sky stops ticking? What happens to human culture when the rhythm that has governed our lives since the dawn of our species is silenced forever? The first thing to break isn't the planet. It is not the laws of physics. It is us. Our minds, our bodies, and the very fabric of our societies. Because for every living thing on this planet, from the smallest microbe to the most complex civilization, the sun isn't just a source of warmth. It is a clock. The only clock that has ever truly mattered. And we've just witnessed it stop. For a few minutes, maybe even a few hours, the sheer shock and panic would be the only thing anyone could focus on. But once the initial wave of terror subsides, a new and deeply strange problem would begin to surface. It wouldn't be a loud, catastrophic failure. It would be a quiet, creeping sense of profound wrongness. A feeling you cannot quite put your finger on, but that you'd feel in your bones. You'd feel tired when you shouldn't, and wide awake in the dead of the artificial night. You'd feel hungry at odd times. Your mood would swing without reason. You would feel, for lack of a better word, unsynchronized. This is the chaos of our internal clocks breaking down. Inside every one of us, deep in our brains, is a master clock. Scientists call it the circadian rhythm. It is an ancient piece of biological machinery, honed by billions of years of life on a spinning planet. This internal clock governs almost everything about our daily existence. When we feel sleepy, when we feel alert, when our bodies release certain hormones, when our metabolism should speed up or slow down. It's the conductor of our personal biological orchestra. But this conductor has always had a guide. Every single morning for all of human history, the first rays of sunlight would strike our eyes and send a signal to this master clock. The signal essentially says, okay, this is the start. Reset the countdown. This is morning. And from that one single cue, our entire 24-hour cycle of life would be set in motion. When the sun vanishes, that morning signal never comes. For the first day or two, your body might try to keep the rhythm going from memory. It'll follow the pattern it knows. But soon, without that daily reset, your internal clock will start to drift. Human beings, when left in total darkness with no time cues, do not naturally stick to a perfect 24-hour day. Our internal cycle is actually a little bit longer, closer to 24 hours. It doesn't sound like much, does it? Just a few extra minutes each day. But it adds up, relentlessly. One day you'll find yourself wanting to go to sleep at what used to be midnight. A week later, you are sleepy at 2 a.m. A month later, your night might begin in the middle of what your watch calls afternoon. It is a permanent, planet-wide case of jet lag, a feeling of being constantly out of sync with everyone and everything around you. And there's no destination you can fly to where you can finally recover. You'd be living in a state of perpetual disorientation, your body's most basic rhythm lost to a silent, timeless darkness. So our bodies are in chaos. But what about our society? We are logical, we are organized. Surely we could just adapt, right? We could agree to live by our mechanical clocks and watches. We have atomic clocks, the most precise timekeepers in the universe. We could simply decide that a day is still 24 hours long, and that work starts at 9 a.m. and ends at 5 p.m. But think about what that really means. What is 9 a.m. in a world without a morning? It is just a number on a screen. A shared fiction we all agree to follow. But the agreement would be fragile. If your body is screaming at you that it is the middle of the night, how productive can you be at your 9 a.m. job? If a whole city's worth of people have internal clocks that have drifted hours apart from each other, how do you schedule anything? How do you organize a school day? How do you run a transportation system? The simple, shared experience of today would be gone. Your today might be wildly different from your neighbor's. The question, how was your day, becomes almost meaningless. Was it my body's day, which felt like a long, sleepless night? Or was it the clock's day, an arbitrary block of hours we've all agreed to pretend is normal? Does the concept of a week even hold? We call it Monday, but what makes it Monday? There's no Sunday night to precede it. There's no weekend to look forward to that feels any different from the weekdays. Our entire calendar is a structure built upon the foundation of a single, repeating event, one rotation of the Earth in front of the Sun. When you remove that foundation, the entire structure starts to wobble. We lose our universal frame of reference. It's like imagining every clock, watch, and calendar in the world stopping at the exact same moment. We'd have no universal way to measure or mark the passage of our lives. We'd be adrift in a sea of endless, undifferentiated time. That fundamental rhythm, the steady beat of day and night that has underscored all of human history, has been silenced. We are a culture untethered from the most fundamental clock we have ever known. And this loss runs even deeper than our biology or our weekly schedules. It cuts to the very core of our cultures, our traditions, and our spiritual lives. So much of what we do, so much of what we've built, is tied to the sun's journey across the sky. Think of the great cathedrals of Europe, with their stained glass windows precisely angled to catch the morning or evening light. Think of the ancient stone circles, like Stonehenge, built to align perfectly with the sunrise on the solstice. These weren't just buildings, they were instruments designed to interact with the sun, to mark its passage, and to celebrate its power. In a world without a sun, they become silent, their primary purpose lost forever. They are monuments to a God that has abandoned the sky. Consider the simple, daily acts of faith. For billions of people, prayer is oriented in a specific direction, often towards the east, towards the sunrise. It is a physical act of turning your body towards the source of light and life. What happens when that direction becomes meaningless? It is just another point on a compass in the unending darkness. The physical anchor for that moment of spiritual connection is gone. Even our modern secular wellness practices are filled with echoes of sun worship. The yoga practice of the sun salutation is a sequence of movements designed to greet the morning sun, to honor its energy. How would it feel to perform that ritual in a cold, dark room, knowing the object of your veneration is gone? It becomes a ghost, a dance for something that is no longer there. All of these practices, from the grandest temple to the quietest personal ritual, were built on a predictable, reliable promise that the sun would always rise. They are expressions of our deep, instinctual connection to that cosmic rhythm. The disappearance of the sun doesn't just plunge us into darkness, it creates a spiritual void. It severs a connection that has defined humanity's search for meaning for millennia. So, you see, the world clock stopping isn't just an inconvenience. It's a fundamental rewriting of the human experience. Our bodies, evolved to dance to a certain rhythm, are now stumbling in silence. Our societies, built on a shared understanding of when, are now lost in a timeless haze. And our cultures, which have spent thousands of years looking to the sky for meaning, now stare into an empty void. We would be a species completely out of our element. Every instinct, every tradition, every biological urge that was shaped by the reliable rising and setting of our star would now be a relic. A piece of obsolete code from a world that no longer exists. We would have to learn from scratch how to live in a world without a heartbeat. A world where time no longer flows, but simply is. And in that endless, star-dusted darkness, we would begin to face the next, and perhaps most brutal, of all the challenges, the coming of the cold. Sound of a gentle, persistent wind begins to subtly fade in, and in that endless, star-dusted darkness, we would begin to face the next, and perhaps most brutal, of all the challenges, the coming of the cold. The first few days and weeks are a scramble. A desperate, worldwide effort to secure power and shelter. But it quickly becomes clear that this isn't a storm we can just wait out. This isn't a winter we can simply endure. The thermostat of our world has been switched off, and the house is losing its heat to the absolute zero of space. The surface of the earth, the stage for all of human history, is doomed. Every city, every forest, every field is on a one-way trip to becoming a frozen monument. So, the great question shifts. It is no longer about saving our world as we knew it. That world is already gone. The question now is, can we save ourselves? And the answer, if there is one, doesn't lie up in the sky we used to watch. It lies deep, deep beneath our feet. The only reason the surface of our planet was ever comfortable for us was because of a delicate balance. We had the sun's fire warming us from above, and the planet's own inner fire warming us from below. We were living in that perfect little sliver of warmth in between. Now, With the sun gone, we only have one source of heat left, the Earth's core. Our best and only chance for long-term survival is to go deep underground, to huddle by the planet's own lingering warmth. It's a strange thing to think about, isn't it? We spend our whole lives aware of the sun, but we rarely think about the fact that we are living on a ball of molten rock with a surprisingly thin crust. The center of the Earth is as hot as the surface of the sun we just lost. It is a gargantuan nuclear reactor that's been running for billions of years, a legacy of the planet's violent formation. For all of our history, that heat has been a distant, abstract fact. Now, it would become our only salvation. Humanity would need to become a species of miners, burrowing back into the warmth of the mother planet. This wouldn't be a case of just digging a few deeper basements. We are talking about the single greatest engineering project in human history, undertaken in the midst of the greatest catastrophe imaginable. We would need to build cities. Not just shelters, but entire, self-sustaining subterranean cities, miles beneath the surface, where the ambient temperature of the rock itself is warm enough to live in. Imagine carving out vast caverns, larger than any we've ever made, and inside them, building our new world. These wouldn't be dark, cramped bunkers. They'd have to be places where a new generation could be born and live their entire lives. They would need spaces for living, for industry, for culture. Think of it less like a fallout shelter and more like an ark, buried in stone instead of floating on water. The pressure at those depths would be immense. The logistics of moving millions of people, along with the resources to keep them alive, would be staggering. Every single thing would need to be considered. Air would need to be scrubbed and recycled endlessly. Water would have to be purified and reused in a perfectly closed loop. Nothing could be wasted. Absolutely nothing. It would be a society built on the principles of a spaceship, because in a very real sense, that's what Earth has become. A rogue, unpowered vessel adrift in the cosmos. And we, the crew, would be sealed inside the engineering deck, trying to keep the lights on. And keeping the lights on would be one of the biggest challenges. The geothermal heat from the Earth's crust could warm our habitats, providing a stable, life-sustaining temperature. That's the passive heat, the ambient warmth we'd be living in. But to power a technological civilization, for light, for computers, for machinery, for life support, we would need a staggering amount of electricity. We would need a new sun, an artificial one. The most viable, and perhaps only, option would be nuclear power. We'd have to gather every bit of our nuclear material and expertise and build a new generation of reactors deep underground. These reactors, safe from the freezing chaos of the surface, would become the beating hearts of our new cities. They would be our artificial suns, providing the light and energy that the real one no longer could. For a few centuries, maybe even a few millennia, if we were resourceful, these contained stars could power the flickering flame of human civilization. It's a profound irony. The very same atomic power that has haunted our dreams for a century with threats of annihilation would become our only tool to fend off a different kind of extinction. So, we have a place to live, and we have power. We are warm, and we have light. But there's another, more fundamental problem. A problem that sits in the pit of every stomach. How do we eat? On the surface, the great engine of life is shutting down. Photosynthesis, the miraculous process that turns sunlight into energy, has stopped. The base of almost every food chain on the planet has been severed. Plants are dying, and soon, everything that eats the plants will follow. The entire system is collapsing. Down in our deep earth shelters, we cannot rely on any of it. There is no sunlight. There are no fields. There is no soil in the way we understand it. Our first attempts at creating food would likely turn to things that are already familiar with the dark. We would become masters of fungi, Vast, humid caverns would be dedicated to farming every conceivable type of mushroom, yeast, and mold. We'd grow them on compost made from recycled organic waste, everything from sewage to the inedible parts of other foods. It is not the most appetizing thought, but in this new world, survival would trump everything. Fungi are decomposers, brilliant at turning death back into life, and we'd be relying on that skill. But mushrooms alone cannot sustain a civilization. They do not provide all the nutrients we need. We'd need to go further. We'd have to get truly creative and learn to replicate a process that already happens in the deepest parts of our oceans, far from the sun's reach. We'd have to develop what's called chemotrophic agriculture. It sounds complicated, but the idea is actually quite simple. Photosynthesis uses light energy. Chemosynthesis uses chemical energy. There are bacteria on Earth, right now, that live near volcanic vents at the bottom of the ocean. They do not eat sunlight. They eat chemicals like hydrogen sulfide or methane that bubble up from the Earth's crust. They take the energy from those chemical reactions and use it to build their bodies, just like a plant uses sunlight. In our subterranean cities, we'd have to harness this. We would essentially become farmers of bacteria. We could build bioreactors, feeding them chemicals that we could mine or produce, and in turn, these bacteria would form the new base of our food chain. We could process them into nutrient-rich pastes and supplements, or we could feed them to other things, like insects or fish in vast enclosed aquaculture tanks. It would be a completely artificial ecosystem, designed and managed by human ingenuity. This is what gritty hope looks like. It's not about finding a magical solution. It is about the hard, dirty, brilliant work of survival. It is the image of engineers planning a geothermal grid while the world above them freezes. It is the image of biologists tweaking the nutrient flows in a bioreactor to eke out a few more calories. It is the story of humanity, faced with the ultimate darkness, refusing to simply give up. It would be a testament to our adaptability. The human drive to figure things out, to solve impossible problems, would be on full display. We would be a species in exile, forced to live in the planet's basement, but we would be alive. We would have used the planet's inner fire to keep warm, our own cleverness to create light, and the planet's own deep chemistry to feed ourselves. We would survive, huddled together, telling stories of a time when the sky was blue and a great golden light warmed the whole world. But while humanity might carve out these small pockets of continued existence, the planet itself, the surface we left behind, would be continuing its own journey. Its final transformation into something cold and silent and utterly alien. But while humanity might carve out these small pockets of continued existence, the planet itself, the surface we left behind, would be continuing its own journey. Its final transformation into something cold and silent and utterly alien. Our world, as we know it, is defined by water. Those vast churning oceans that cover over 70% of its surface are the planet's great thermal battery. They absorb the sun's energy, store it, and move it around, creating our weather, our climate, our entire biosphere. And so when the sun's energy is cut off, the first and most dramatic story of this long night is the story of the oceans. You might imagine an instant flash freeze, like something from a movie. But the reality is far slower, and in a way, far more profound. Water has an incredible capacity to hold on to heat. It is why a hot water bottle stays warm for hours. Now, imagine a hot water bottle the size of a planet. That's the kind of thermal inertia we are talking about. For the first few weeks, the surface of the sea would steam. A thick, eerie fog would blanket the coastlines as the relatively warm water met the rapidly freezing air. But that warmth would be pouring out into the endless cold of space, a bank account with no more deposits. The surface temperature of the water would begin to plummet. Soon, the first ice would appear. Not the gentle crystalline structures of a winter frost, but vast solid sheets forming at the poles and creeping outwards. The process would accelerate. Coastlines would become locked in ice. Harbors and bays that once saw the gentle lapping of waves would fall silent, frozen solid. The great currents, the planet's circulatory system, would slow and eventually stop, choked by the ever-expanding ice. Within a year, or perhaps a few, the entire surface of the world's oceans would be covered in a thick crust of ice. Imagine every ocean, every sea, becoming a single unbroken skating rink, stretching from continent to continent. The sound of waves, a rhythm that has defined our planet for billions of years, would simply cease. The world would fall into a new kind of silence. But this is where things get interesting. This new global ice sheet, while a symbol of death on the surface, would actually become a temporary lifeline for the depths. Ice, it turns out, is a fantastic insulator. It's why igloos work. The thick layer of ice would act like a planetary duvet, trapping the Earth's residual geothermal heat, the warmth still radiating from its core, and protecting the deep water below from the absolute cold of space. So, for a very, very long time, beneath that silent, frozen roof, the deep oceans would remain liquid. Hundreds of years, perhaps even thousands. It would be a strange, dark world down there. No sunlight had ever reached it, so the darkness wouldn't be new. But the pressure from the ever-thickening ice sheet above would be immense. Life, especially the kind we find huddled around hydrothermal vents, might continue, completely unaware that its world had fundamentally changed. They never knew the sun, so they would never know it was gone. It's a strange and comforting thought, in a way, that even as the surface becomes a monument to cold, the heart of the ocean would continue to beat, preserving a faint echo of the warm, wet planet Earth used to be. For a time. But even the planet's own inner fire isn't infinite. And the cold of interstellar space is patient. Over the course of centuries and millennia, that cold would slowly, relentlessly creep downwards. The ice on the surface would get thicker and thicker, meter by meter, century by century. The insulating blanket would become a frozen tomb. The pressure would be unimaginable. The very structure of the ice would change under the weight, forming exotic high-pressure variants that we only see in laboratories. The line between liquid and solid would be pushed deeper and deeper, until eventually the battle was lost. The last pockets of liquid water, deep in the crushing abyss, would finally give up their warmth and freeze. And with that, the process would be complete. The Earth, our vibrant blue marble, would become a solid ball of ice. A wanderer in the dark, with no liquid heart left to beat. It would be a world entirely preserved, a museum of a planet, but a dead one. Adrift and silent. This deep, deep freeze of the oceans is just the first act of the planet's transformation. Because as the surface temperature continues to fall, something even more bizarre, more alien, begins to happen. Something we never think about, because our world is just so wonderfully, comfortably warm. The atmosphere itself begins to freeze. We think of air as, well, as nothing. It's just there. But the nitrogen, the oxygen, the argon that make up our atmosphere are all just gases because of the sun's energy. They have a boiling point and a freezing point, just like water does. It's just that those points are at temperatures so incredibly, unimaginably low that we never encounter them. Earth is about to encounter them. As the surface temperature, now shielded from any warmth, plummets past 100, then 150, then 200 degrees below 0 Celsius, the sky begins to change. The first to go would be the carbon dioxide, freezing out of the air at around minus 80 degrees Celsius, falling as a fine, dry ice snow. But that's just a tiny fraction of our atmosphere. The real show begins when the temperature drops to around minus 196 degrees Celsius. At this point, nitrogen, which makes up 78% of our air, can no longer remain a gas. The sky itself would begin to condense. A thick, otherworldly mist of liquid nitrogen would form close to the ground. Puddles, then lakes of liquid air would pool in the lowest lying valleys. It's a concept that almost breaks the mind. Imagine standing on a frozen ocean, and the very air around you starts to turn into a liquid. And as the temperature keeps dropping, past minus 210 degrees, that liquid nitrogen would freeze solid. It would begin to snow. Not water ice, but nitrogen ice. A constant, gentle, silent snowfall of frozen air, blanketing the entire planet in a new layer of white. Oxygen follows a similar path, condensing and freezing at slightly lower temperatures. So after the nitrogen snow, there would be a layer of pale blue oxygen frost. The very air we breathe, the stuff that has fueled complex life for 500 million years, would become just another layer of ice on a dead rock. This is the source of our central analogy for this process. The Earth's atmosphere really is like a blanket. It holds in the sun's warmth and makes our world livable. But without the sun, the blanket isn't nearly enough to fend off the absolute cold of the cosmos. And in this ultimate chill, the blanket itself gets so cold that it freezes and falls down like a final, silent snow. Once the atmosphere has rained down and frozen onto the surface, the Earth would be almost unrecognizable. It would be a silent, airless world. There would be no wind, no weather, no sound, because sound needs a medium to travel through. The silence of the frozen oceans would now be joined by the absolute vacuum of a world with no sky. The stars would be magnificent. With no air to scatter the light, they would be sharp, unblinking points of brilliant diamond dust against a backdrop of perfect velvet black. You could see the Milky Way not as a faint milky smudge, but as a vast textured river of light blazing from horizon to horizon. It would be the most spectacular and the most terrifying view imaginable. From a distance, the planet would have a strange new beauty. It would be coated in this layer of frozen atmospheric gases, a delicate, miles-thick shell of nitrogen and oxygen ice over the water ice below. It would glint in the faint starlight, a pale, ghostly wanderer. Our Earth would have become indistinguishable from the moons of the outer solar system. It would look like Pluto or Neptune's moon Triton, worlds we view as alien and impossibly remote. Our home, with all its mountains and canyons buried deep beneath layers of frozen water and frozen air, would have joined their ranks. It would just be another silent, airless rock, a testament to the fact that a planet is nothing without its star. It would be a world waiting for a dawn that will never, ever come. It would just be another silent, airless rock, a testament to the fact that a planet is nothing without its star. It would be a world waiting for a dawn that will never, ever come. But before that final, absolute silence, before the last of the air freezes and falls like snow, there would be us. The survivors, if any, tucked away deep beneath the frozen surface. We've talked about the practicalities of this survival, the geothermal heat, the nuclear-powered lights, the challenge of growing food in the dark. We can imagine, with enough time and ingenuity, solving the engineering problems. We could build shelters to protect our bodies from the cold. But what would we do to protect our minds from the darkness? Because beyond the incredible physical challenges, there lies a deeper, more insidious problem. It's the kind of problem you can't build a machine to fix. It's the quiet, creeping dread that would settle into the human spirit when it realizes it is living in a tomb, adrift in a graveyard. The greatest challenge wouldn't be surviving the cold. It would be surviving the dark. Think about our relationship with darkness. It's complicated. We have a name for the profound fear of it: nyctophobia. It's one of our oldest, most primal fears, something baked deep into our evolutionary DNA. For our ancient ancestors, the dark wasn't just an absence of light, it was an active presence. It was the cloak that hid the predator, the veil that concealed the cliff's edge. Darkness meant danger. The sun meant safety. Now, imagine that ancient hardwired fear becoming the permanent, unchangeable state of reality. The very concept of day would cease to exist. Every single moment of your life would be lived inside that primal fear, the one that makes a small child pull the blankets over their head. Except now, there's no blanket thick enough to hide from this kind of darkness. There's no sun coming in the morning to chase it away. That instinct, that whisper in the back of your mind that says be careful in the dark, would never, ever turn on. It is a psychological burden that's difficult to even comprehend. To live your entire life in a state of high alert, your very biology screaming that you are in constant, mortal danger, even when you are safe within the walls of your subterranean city. The threat is no longer a lion in the bushes. The threat is the entire universe. It's a fundamental inversion of our existence. We are creatures of the light, suddenly and permanently banished from it. But the fear of the dark is only the beginning. There's a more subtle, more philosophical weight that would begin to press down on us. It is the loss of a universal constant. Think about it for a moment. The sun is the one thing that every single human being who has ever lived has had in common. It doesn't matter what country you are from, what language you speak, what you believe, or what you doubt. The sun has been there. Its rising and setting is the most fundamental rhythm of life on this planet. It's the metronome that our societies, our bodies, and our very consciousness have been set to for millions of years. It is the ultimate given. Its disappearance would be more than just a loss of light and heat. It would be the loss of our most profound connection to the cosmos and to each other. It would create a sense of cosmic loneliness that is almost impossible to put into words. We wouldn't just be physically untethered from our star, we would be psychologically adrift. The sun is like a comforting background hum that we've never really noticed until it's suddenly gone. Its absence would be a psychological silence that's absolutely deafening. Every culture has looked up at that same sun. It has been the anchor for our calendars, the inspiration for our gods, the silent witness to our entire history. To lose it is to lose a piece of our collective identity. It's the realization that we truly are alone, on a tiny rock falling through an endless, empty blackness. That sense of abandonment, the feeling of being forgotten by the universe, might be a wound too deep for the human psyche to ever truly heal. In recent years, we've developed a term for a specific kind of modern sadness: solastalgia. It's not nostalgia, which is a longing for a past you can no longer return to. Solastalgia is the distress and homesickness you feel when you're still at home, but your home has been irrevocably changed for the worse. It's the grief you feel when a beloved forest from your childhood is cut down, or when a familiar coastline is eroded by the sea. It's a feeling of loss for a world that's disappearing right in front of your eyes. Now, imagine solastalgia on a planetary scale. An unimaginable scale. It wouldn't just be the loss of a familiar landscape. It would be the loss of the very concepts of landscape, of horizon, of sky. Every survivor would be haunted by the memory of a warm, vibrant world they could never experience again. They would be living on Earth, but it would no longer be their home. It would be a ghost of their home. This planetary solastalgia would be the defining emotional state of the human race. A perpetual mourning for a lost world. How could you ever feel truly at peace, knowing that just a few miles above your head lies a frozen wasteland that was once filled with oceans and forests and bustling cities? How could you not feel an ever-present ache for the warmth of sunlight on your skin? A sensation you can describe to your children, but never, ever share with them. It's a unique kind of grief. It's the grief for everything. For the color blue. For the feeling of a summer breeze. For the simple, thoughtless act of looking up. The entire surface of the planet becomes a monument to what was lost, and every person alive would be a curator of that global museum of sorrow. The world is gone, but you are still in it. That's solastalgia. And this would be its ultimate, most tragic expression. So, in this world of perpetual darkness and perpetual grief, what would happen to us? What would happen to our culture? Our art, our music, our stories, the very things that make us human, how would they change in a world that has been so fundamentally broken? Art, as we know it, is so often about capturing light. From the Impressionists, trying to paint the fleeting light of a sunset, to a photographer capturing the shadows of a city street. What does a painter do in a world without light? Perhaps visual art would lose its primacy. Maybe sculpture, art that you can experience through touch, would become the dominant form. We would create beauty, not for the eye, but for the hand, tracing the curves and edges of a statue in the carefully rationed artificial light of a deep earth dwelling. And what about our music? Perhaps it would become more important than ever. In the absence of visual beauty, music would be our primary way of painting pictures. Songs might become longer, more intricate, telling epic stories of the sun times. They would be filled with soaring melodies, meant to evoke the feeling of a wide open sky for people who have only ever known the confines of a cavern. Music would have to carry all the emotional weight that a beautiful view once did. It would be our cathedral, our sunset, and our starry night all rolled into one. But it's our stories that would see the most profound transformation. For the first few generations, the stories would be memories. Grandparents would tell their grandchildren about a strange and magical time when the entire world was lit by a giant, warm lamp in the sky. They'd describe the impossible color of the sky, the green of the trees, the feeling of rain on your face. To these children, born in the deep dark, these stories would sound like the wildest fantasy. The sun would become a mythological figure, a lost god from a paradise world. Blue and green would become mythical colors, words that exist only in old books and whispered legends. The entire history of humanity, up to that point, would read like a fairy tale, a story of a magical kingdom that was lost to an eternal night. Our human drive to create wouldn't vanish. Our need for beauty and meaning wouldn't just disappear. But they would be forced to adapt, to find new ways to express the human experience in a reality that is alien to us. We would still create, still sing, still tell stories. But all of it would be haunted by the ghost of a light that no one alive has ever seen. All of our art would become a form of elegy, a beautiful and heartbreaking song for a world that no longer exists. And as generations pass, you have to wonder, would the memory fade? Would the truth of what was lost become so mythologized that it loses its power to cause pain? Or would the longing simply be passed down, a genetic inheritance of sorrow? It leaves us with a quiet, lingering question. For those future generations, born and raised in the endless dark, surrounded by the artificial glow of their deep earth cities, would they still dream of blue skies? Would they still dream of blue skies? It's a haunting thought, isn't it? Generations living in the deep, knowing the sun only as a legend, a myth from a long-lost past. But this very thought, this entire exploration of a world without a sun, it brings up an even more fundamental question. How do we even know enough to ask? The question itself, what if the sun vanished instantly? Might seem simple, but it is not. It is actually a deeply modern question, one that our ancestors simply couldn't have conceived of in the same way. The ability to even frame that sentence is the final product of a journey that took thousands of years. A journey of looking up at that same bright circle in the sky and slowly, piece by piece, figuring out what it truly is. That question is a monument, built over centuries by human curiosity. So, let's trace that journey. Let's rewind the clock, not just to the moment the sun disappears, but all the way back to a time when our understanding of it was completely different. For most of human history, if you asked someone what the sun was, you wouldn't get an answer about nuclear fusion or gravitational fields. You'd get a story. You'd be told about a god. Imagine you are an ancient Greek, standing in a field of olive trees. For you, that golden light warming your face isn't a star. It's Helios, the sun god, riding his magnificent golden chariot, pulled by 4 fiery horses across the sky each day. When evening comes, he dips below the western horizon and travels through the world ocean back to his rising place in the east, ready to begin his journey again the next morning. It's a beautiful idea, isn't it? It gives the universe a sense of personality, a daily drama. The sun isn't just an object, it's a character in the story of the world. In ancient Egypt, it was the god Ra, sailing his solar barge across the heavens, battling the serpent of chaos, Apep, every single night to ensure the dawn would come. For the Norse, it was Sol, a goddess forever pursued by the great wolf skull. In these worlds, the sun's disappearance isn't a physics problem, it is a divine tragedy. It means the gods have failed, or the forces of chaos have finally won. The fear was real. They saw a preview of it during every solar eclipse, but the explanation was mythological. The sun wasn't a thing that could just vanish. It was a being that could be defeated, or captured, or killed. You see the subtle difference. Their fear was rooted in story, while ours is rooted in mechanics. So, what had to change for us to get from a divine chariot to a giant star? The first, and perhaps the biggest, psychological leap was what we now call the Copernican revolution. For millennia, the answer to how does the universe work was obvious. You just had to look. The sun rises in the east, travels across the sky, and sets in the west. The moon does the same. The stars wheel overhead. Clearly, everything moves around the earth. We are the stable, unmoving center of it all. It feels right. It is intuitive. But in the 16th century, a Polish astronomer named Nicolaus Copernicus proposed a radical and frankly unsettling idea. He suggested that our intuition was wrong. He proposed that the earth was not the center of the universe. The sun was. It wasn't the sun that was circling us. It was Ashwe who were circling it. It's almost impossible to overstate what a profound shift this was. This wasn't just about redrawing diagrams of the solar system. This was about dethroning humanity from its privileged place at the very heart of creation. Suddenly, we weren't the main characters in the story. We were just passengers on a rock, one of several, all going around in a giant loop, around a central star. Earth was demoted. And in that demotion, the sun was promoted. It was no longer just a lantern for us, a light that circled our stage. It was the anchor, the center of gravity, the thing that our world depended on. This was the first crucial step. The sun had to stop being a character in our story and become the stage itself, the central pillar holding everything up. But even with Copernicus, the picture wasn't complete. We knew in what way was happening. We were orbiting the sun, but we had no idea how. What was this invisible force that kept our planet locked in this cosmic dance? Why didn't Earth just fly off into space? The answer to that came from a man who saw an apple fall from a tree, Sir Isaac Newton. Newton gave us the laws of universal gravitation. He explained that the sun wasn't holding us in place through magic or divine will. It was holding us with gravity, the very same force that made the apple fall to the ground. He realized that this force wasn't just here on Earth, it was everywhere. It was a universal law. The sun, being unimaginably massive, exerts a powerful gravitational pull on everything around it, including our tiny planet. Our forward momentum from the formation of the solar system wants to send us flying off in a straight line, but the sun's gravity constantly pulls us inward. The result of this perfect balance is a stable orbit. And with that, our understanding of the sun took another giant leap. It transformed again. It wasn't a god on a chariot, and it wasn't just a mysterious central point. For the first time, the sun became a physical object governed by knowable mathematical laws. It was a cog in a grand, predictable, and understandable machine. The universe, in Newton's view, was like a giant clock. God might have wound it up, but it ticked along according to these perfect, unchanging laws. This is the moment where our question, what if the sun vanished, starts to become scientifically thinkable. Because once something is part of a machine, you can ask what happens if you remove it. Once the sun is just a massive object with a gravitational pull, you can start to wonder what would happen if that object and its pull were suddenly gone. You couldn't ask what would happen if Helios's chariot vanished, because that's just a story. But you can ask what would happen if a massive gravitational anchor at the center of our solar system disappeared. The question was now possible, but the answer was still incomplete. According to Newton's laws, the force of gravity was instantaneous. It acted across any distance in no time at all. So, in a Newtonian universe, if the sun were to vanish, the Earth would instantly, at that very same moment, stop feeling its gravitational pull and fly off into space. The darkness would come later, 8.5 minutes later, because we already knew that light had a finite speed. But the gravitational effect, the feeling of being flung from our cosmic carousel, would be immediate. For over 200 years, that was the best answer science could offer. An instant release, followed by darkness a few minutes later. And then, in the early 20th century, another mind came along and changed the rules of the universe one more time. Albert Einstein. Einstein's theory of general relativity gave us a completely new way to think about gravity. He said that gravity isn't a force that pulls across a distance. Instead, he described it as a curvature, a warp in the very fabric of space-time. This is where our central analogy for this journey comes in handy. Understanding the sun is like slowly adjusting the focus on a microscope. For the ancients, it was a blurry, divine shape. Copernicus brought the basic form into view, a central object. Newton sharpened the focus, revealing the mechanical laws of gravity that governed it. But Einstein adjusted the fine-tuning knob and revealed the intricate, almost unbelievable machinery working at the deepest level. He asked us to imagine space-time as a giant, flat, flexible rubber sheet. A massive object like our sun is like a heavy bowling ball placed in the middle of that sheet. It creates a deep dent, a curve in the fabric. A smaller object, like the Earth, is like a marble rolling nearby. It gets caught in that curve, and it orbits the bowling ball, following the curve in the sheet. That, Einstein said, is gravity. It's not a pull, it's the shape of space itself. Now think about our question in this context. What if the sun vanished instantly? In Einstein's universe, you're not just removing a source of a pulling force. You're removing the bowling ball from the rubber sheet. And what happens when you do that? Does the sheet instantly snap back to being flat? No. The dent would vanish, but a ripple, a wave of flattening, would travel outward from the center. That ripple, the disturbance in space-time, would travel at a specific, finite speed. And that speed, Einstein calculated, is the speed of light. This was a staggering revelation. It means that the news of the sun's gravitational disappearance travels at the exact same speed as the news of its visual disappearance. The light from the sun and the gravity from the sun are both bound by the same cosmic speed limit. And so, the very premise of our entire story, the core idea we began with in part 1, that 8-minute delay, it is a gift from Einstein's mind. The idea that darkness and our flight into the void would not happen at the same time for us here on Earth, that the light would go out first, and then we would be released, that's a Newtonian idea. But the profound and correct understanding is that both messages, the last ray of light and the last wave of gravity, are on the exact same 8.5-minute journey to Earth. They arrive together. We would be plunged into darkness at the very same moment we are flung into the abyss. Do you see how far we've come? From a god on a chariot, whose absence would be a tragedy, to a star whose absence is a complex problem in relativistic physics. The journey has been one of removing the magic and replacing it with mechanics, of taking the sun out of the realm of myth and placing it firmly in the world of measurable, understandable phenomena. Each step along the way, from Copernicus to Newton to Einstein, chipped away at the mystery and replaced it with a deeper, more profound kind of wonder. An intellectual wonder. The wonder not of a story that explains things, but of a mechanism so vast and elegant that our minds can just barely grasp it. And that's why the question itself is so remarkable. It is a sign of how much we've learned. It is a question that contains within it the Copernican revolution, Newton's laws, and Einstein's relativity. It is a question that acknowledges the sun is a physical object, that it has gravity, and that the effects of its existence are limited by the speed of light. It's the ultimate expression of our cosmic curiosity, born from millennia of staring up at that same life-giving star and never, ever being satisfied with not knowing what it truly is. And by asking what we would lose if it were gone, we are, in a way, celebrating everything we have gained in understanding it. It's the ultimate expression of our cosmic curiosity, born from millennia of staring up at that same life-giving star and never, ever being satisfied with not knowing what it truly is. And by asking what we would lose if it were gone, we are, in a way, celebrating everything we have gained in understanding it. But our understanding of the universe has revealed some truly strange things. We've journeyed through the freezing of the atmosphere, the end of all surface life, and the silent, lonely drift of our planet through the void. It feels like a complete and total end. An equation where, if you remove the sun, the answer is 0. No light, no heat, no life. The story, it would seem, is over. And yet, what if that equation was wrong? What if life, in its most stubborn and ingenious forms, had already found a loophole? What if, in the deepest, darkest corners of our own world, there were entire ecosystems that had never needed the sun to begin with? Long before our hypothetical catastrophe, here on our warm, sunlit Earth, scientists were discovering life in places that seemed utterly impossible. They found tiny organisms, which we now call extremophiles, thriving in boiling hot springs, in pools of acid, deep within solid rock, and in the hypersaline waters of lakes where nothing else could survive. It was a profound revelation. Life was tougher, more adaptable, and far stranger than we had ever imagined. It seemed that wherever there was even a sliver of an opportunity, a drop of liquid water, and a source of energy, life would find a way to wedge its foot in the door. But none of these discoveries could prepare us for what we would find in the one place on Earth that is already a world without a sun, the deep ocean floor. Imagine sinking down, deeper and deeper, into the sea. You pass through the sunlit zone, where light filters through the blue powering plankton and coral reefs. You go deeper, and the light fades to a dim twilight. Then, deeper still, until you cross a threshold into a realm of absolute, permanent blackness. It's a place of crushing pressure, thousands of pounds per square inch, and temperatures that hover just above freezing. For centuries, we assumed this abyssal plain was a barren desert, a place where only the hardiest scavengers could survive on the gentle rain of organic debris falling from the world of light miles above. We couldn't have been more wrong. In 1977, a deep-sea submersible exploring the Galapagos Rift made one of the most stunning biological discoveries of all time. As its lights cut through the darkness, it didn't find a barren wasteland. It found an oasis. A bustling, vibrant city of life, teeming with creatures straight out of science fiction. There were giant white clams, ghostly pale crabs, and, most bizarre of all, dense thickets of tube worms, some as tall as a person, swaying in the currents with blood-red plumes. None of this made any sense. There was no light. There was no photosynthesis. The very foundation of life as we knew it was absent. So what was powering this impossible garden in the dark? The answer was coming from the Earth itself. The submersible had stumbled upon a hydrothermal vent, a fissure in the planet's crust where seawater seeps deep into the rock, is superheated by magma, and then erupts back into the ocean. These vents, often called black smokers, look like underwater chimneys, belching out a plume of superheated water that's black with dissolved mineral. The water is scalding hot, sometimes over 400 degrees Celsius, or 750 degrees Fahrenheit, and it is loaded with chemicals that are toxic to most life on the surface. Chemicals like hydrogen sulfide. And it is this chemical brew that provides the secret. It's the key to the loophole. On the surface, life runs on photosynthesis. Plants use the energy from sunlight to turn carbon dioxide and water into sugar, creating the energy that fuels almost every food web on the planet. It's a process based on light. But down here, in the eternal night of the deep sea, life runs on a different system. It runs on achemosynthesis. Instead of using light from the sun, the bacteria that swarm around these hydrothermal vents use chemical energy. They essentially eat the toxic hydrogen sulfide pouring out of the vents. They take this chemical, which smells like rotten eggs to us, and use its energy to create sugars, just like plants do with sunlight. They become the foundation of a brand new, independent food web. They are the producers. They are, in a very real sense, the sun for this deep, dark world. Everything else in this bizarre ecosystem depends on these chemical-eating bacteria. The giant tube worms, for example, have no mouth and no digestive tract. Instead, their bodies are packed with these bacteria, which feed them from the inside out. The crabs and shrimp and fish that live here either feed on the thick mats of bacteria that coat the rocks, or they feed on the things that feed on the bacteria. It is a completely self-contained world. It is a city that runs on its own power grid, entirely separate from the global one we all rely on. If the sun, our global power plant, were to suddenly shut down, this city's lights wouldn't even flicker. They wouldn't notice. They couldn't notice. Their entire existence is built upon a different source of power, the inner fire of the planet itself. Now, let's return to our orphan planet, flying through the cold of interstellar space. On the surface, it is a frozen hell. The great cooling has happened. The oceans are sealed beneath a crust of ice that is now miles thick. The atmosphere has frozen solid, snowing down as a fine layer of nitrogen and oxygen crystals. The world is silent, airless, and unimaginably cold. Any trace of the life we once knew, the forests, the grasslands, the birds in the sky, is gone, locked away under a permanent blanket of ice and frozen air. Humanity, if it has survived, is huddled in deep subterranean shelters, powered by the same geothermal heat, a pale imitation of the world they lost. For them, it is an age of darkness, memory, and struggle. But down in the crushing blackness, beneath the miles of solid ice that now form the ocean's roof, The black smokers are still smoking. The planet's core is still hot. The vents are still pouring out their life-giving chemical soup into the water. And the bacteria are still feasting on it. For the tube worms and the ghostly fish, the blind crabs and the strange mollusks, nothing has changed. Not a single thing. Their world was already one of absolute darkness and immense pressure. Their world was already warmed, not by a distant star, but by the very heart of their own planet. The chaos, the freezing, the end of the world that happened miles above their heads is a story from another universe. It's an event that is totally, completely, and utterly irrelevant to them. This offers a sliver of hope, doesn't it? A surprising and deeply profound optimism. It tells us that life is not a fragile flower that can only bloom in the perfect, sun-drenched garden of a world like ours. It is more like a stubborn weed, capable of growing in the cracks of the pavement, in the most hostile and unlikely of places. Our definition of life, for so long, was inextricably tied to the sun. We looked for planets in the habitable zone, the Goldilocks region around a star where liquid water could exist on the surface. But these deep-sea ecosystems prove that the habitable zone might be much wider than we thought. Maybe you do not need a sun at all. Maybe all you need is a geologically active world with liquid water, even if that water is trapped beneath a thick shell of ice. Planets like Jupiter's moon Europa or Saturn's moon Enceladus are now seen as prime candidates in the search for extraterrestrial life for this very reason. They are snowball worlds, covered in ice, far from the sun's warmth. But we have evidence that they have liquid water oceans beneath their frozen shells, and that they are kept warm by the tidal forces of their giant parent planets, creating geothermal activity on their ocean floors. It's possible that, right now, there are hydrothermal vents on those moons, powering ecosystems just as strange and wonderful as the ones on our own planet's seafloor. Life, it turns out, might not be a function of starlight, but a function of planetary life itself. It might be a natural consequence of a wet, rocky world with a hot heart. So even as our hypothetical Earth becomes a dead, frozen rock on the surface, its story isn't quite over. Deep inside, in these secret pockets, life's ancient spark is preserved. It is not our life. It is not a life of consciousness or memory or stories about the color blue. It is a life that is alien and strange and utterly indifferent to our fate. But it is life. It is a quiet testament to the fact that even when the ultimate source of energy is taken away, the universe is so full of energy, so full of possibilities, that something, somewhere, will find a way to carry on. It's a truly humbling thought. We see ourselves as the pinnacle of life on Earth, the masters of this planet. But in this dark future, we would be the refugees, struggling to survive in artificial bubbles, while the true natives of the dark, the creatures of the abyss, would continue their existence completely unperturbed. They were here long before us, and in this scenario, they would be here long after. The discovery of these ecosystems changes everything. It reframes the story of our planet from a singular sun-dependent miracle to a world with multiple, independent footholds for life. One is big, obvious, and glorious, the world of photosynthesis. The other is hidden, secret, and powered by a different kind of fire. And it is this hidden branch of life that would, in the end, be the planet's last survivor, a quiet, flickering candle in the unending darkness. The other is hidden, secret, and powered by a different kind of fire. And it is this hidden branch of life that would, in the end, be the planet's last survivor, a quiet, flickering candle in the unending darkness. It's a strange thought, isn't it? That life could carry on in the deepest, most absolute darkness we can imagine. But our entire journey so far has been about the sun's absence, about the quiet horror of a star simply winking out of existence. We've imagined the world getting colder, quieter and darker, a slow fading into a cosmic night. But the truth is, our star doesn't have to vanish to plunge us into darkness. In fact, one of the greatest threats we've ever faced from the sun came not from its absence, but from its overwhelming, violent presence. Sometimes, the greatest danger isn't when the sun goes away, it is when it fights back. To understand this, we have to travel back in time. Not millions of years, but to a time that feels surprisingly modern. The year is 1859. The world is being stitched together by a new kind of magic, the electric telegraph. For the first time, a message can cross a continent in minutes, not weeks. It was the internet of its day, a fragile web of wires draped across the landscape, humming with the promise of a connected future. And on the first day of September of that year, an English astronomer named Richard Carrington was in his private observatory, sketching sunspots. It was a routine task, something he'd done hundreds of times before. But on this morning, something was different. Through his telescope, he saw two brilliant flashes of white light erupt from the surface of the sun. They were so intense, they were visible to the naked eye, a feat of solar power that was, at the time, completely unheard of. He was the first human being to ever witness what we now call a solar flare. He was stunned. He knew he'd seen something important, but he couldn't possibly have known what was coming next. He had just witnessed the sun firing a warning shot across the bow of humanity. Because that flash of light was just the beginning. It was accompanied by something else, something invisible and immensely powerful. A vast cloud of magnetized plasma, a cosmic hurricane of charged particles, was now hurtling through space, aimed directly at our planet. This wasn't light, which travels at, well, the speed of light. This was a physical wave of matter and energy. It was slower, but it packed an incredible punch. It took just under 18 hours for this wave to cross the 93 million miles between the sun and Earth. And when it hit, our planet's magnetic shield, the invisible force field that protects us from solar radiation, was overwhelmed. It was like a dam bursting. That solar storm slammed into our upper atmosphere, and all across the globe, our brand new, cutting-edge technology began to scream. The telegraph network, that symbol of human ingenuity, went haywire. The wires became supercharged with electrical current from the sky. Telegraph pylons threw sparks. Operators reported getting powerful electric shocks from their equipment. Some of the telegraph paper, the very medium for these new lightning-fast messages, spontaneously burst into flames. The system was so overloaded that some operators disconnected their batteries and found that they could still send messages, powered purely by the electricity being generated in the atmosphere by the storm. The sky itself had become a battery. Think about that for a moment. Humanity builds its first global communication network, and the sun, in a fit of cosmic rage, hijacks it. It was a profound, humbling reminder of where the real power in the solar system resides. We had built a web to talk to each other, and the sun used it to shout. But the effects weren't just technological. They were breathtakingly beautiful and deeply unsettling. The energy pouring into the atmosphere supercharged the auroras, the northern and southern lights. But these weren't the familiar, gentle glows seen only in the far polar regions. These were auroras on a planetary scale. They were seen in Cuba, in the Caribbean. They were seen in Colombia, near the equator. People in the Rocky Mountains reported the light was so bright they could read a newspaper by its glow in the middle of the night. Gold miners woke up and started making breakfast, convinced the sun had risen hours early. The sky was filled with curtains of red, green, and purple light, dancing in places they had never ever been seen before. It must have been an absolutely terrifying spectacle. For most of human history, an event like this would have been interpreted as a divine omen, a sign of the world's end. A sky on fire. And in a way, it was an omen. It wasn't the end of the world, but it was a preview. It was a warning of just how fragile our connection to this star truly is. This event, which we now call the Carrington event, was the most powerful solar storm ever recorded in human history. And it happened in 1859. A time of steam engines and iron. Imagine, just for a second, what would happen if a storm of that exact same magnitude were to hit us today. It's not a comfortable thought. Back then, the only technology truly vulnerable was the telegraph. The damage was widespread, but contained. Today is a different story. Our entire modern civilization is a house of cards built on a foundation of electricity and microchips. We've spent the last century and a half wrapping our planet in a delicate electronic nervous system. Satellites, power grids, GPS, the internet, banking systems, air traffic control. It all depends on the steady, predictable flow of electrons. A modern Carrington event wouldn't just make telegraphs spark. It would be a planetary-scale shutdown. The first casualties would be in orbit. Our cloud of satellites, the unseen architecture of modern life, would be battered by charged particles. Many would be fried instantly. Their delicate electronics would be short-circuited, turning them into dead pieces of metal. That means no GPS. No satellite television. No international phone calls. Much of our weather forecasting, gone in an instant. Then, the storm would hit the power grid. The same effect that supercharged the telegraph wires in 1859 would induce massive, uncontrollable currents in our high-voltage power line. Transformers, the crucial nodes of the entire grid, would overheat and explode. Not just one or two, but potentially hundreds, even thousands of them across entire continents. And this is the crucial part. These aren't like fuses you can just flip back on. Large transformers are custom-built, weigh hundreds of tons, and take months, sometimes years, to build and install. If a significant portion of a nation's grid is destroyed, we are not talking about a blackout that lasts a few hours or a few days. We are talking about a blackout that could last for months or years. And what does a world without power for months or years look like? It's a different kind of darkness than the one we've been exploring. It is not the cold, silent dark of a missing sun. It is a chaotic, desperate darkness. Without electricity, the pumps that bring clean water to our cities would stop. The systems that handle our waste would fail. Our just-in-time food delivery systems would grind to a halt. Supermarket shelves would be bare in a matter of days. Hospitals would run on backup generators for a while, but then fall silent. No modern medicine. The financial system, which is really just a series of electronic records, would cease to exist. All of it just gone. And of course, no internet. No phones. No way to communicate, to coordinate, to call for help. It would be a new dark age. A dark age we built for ourselves, not by losing the sun, but by becoming too dependent on our own cleverness, forgetting that all of it exists at the mercy of that star 93 million miles away. The Carrington event serves as a stark, historical reminder. It's proof. It's the universe showing us that our relationship with the sun isn't just one of a gentle provider of light and warmth. It is a relationship with a vast, powerful, and sometimes violent nuclear furnace. We live downstream from an active volcano. Our entire technological society has been built during a period of relative solar calm. We've been like people building a city on the banks of a river that hasn't flooded in 100 years. We forget it can flood. We forget its power. So, while we've been exploring the terrifying hypothetical of the sun vanishing, a real documented event from our own history shows us a different path to darkness. A path paved not with cold and silence, but with fire from the sky. It highlights a profound vulnerability at the heart of our modern world. We are utterly dependent on our star behaving in a very specific, predictable way. We need it to be not too hot, not too cold, not too distant, not too close. And as the Carrington event showed us, we also need it to be not too angry. This real-life story changes the nature of our thought experiment, doesn't it? The fear is no longer just about the sun's absence. It's also about its presence. The sun is the source of all life, the engine of our world. But it also possesses the power to cripple our civilization with a single colossal burst of energy. It shows us that we exist in a very narrow, very fragile band of safety. A cosmic sweet spot. And our survival depends on staying within it. The Carrington event was a momentary deviation, a brief glimpse outside that safe zone. And even 1859, it was enough to set the world's wires on fire. Today, it would be enough to bring our world to a halt. It is the ultimate paradox. The very thing that gives us everything can also take everything away. Not by leaving us, but simply by reminding us of its true unimaginable power. The very thing that gives us everything can also take everything away. Not by leaving us, but simply by reminding us of its true unimaginable power. But what if the danger isn't a sudden violent outburst? What if it is the opposite? What if the threat is silence? An absence? After all the chaos and the cold, after the deep psychological shock, we are left with a question that's less about physics and more about philosophy. It is a question of cause and effect. A question of payment. We are forced to look at a kind of cosmic receipt, a final tally of everything we were ever given, and the one single source it all came from. Think about the concept of causality. It's a simple, intuitive idea. For every effect, there is a cause. A ball moves because you kicked it. A plant grows because a seed was planted and watered. Our entire understanding of the world, of life itself, is built on this chain of events, one thing leading to another. Well, if you trace the chain of life on Earth back far enough, past every event, past every ancestor, past the first single-celled organism, you find the first link. The ultimate cause. The sun. Its disappearance, in this scenario, isn't just an event. It is the erasure of the primary cause of our very existence. It's the universe presenting a final, non-negotiable invoice. Let's make this tangible. Think about the last meal you ate. Maybe it was a sandwich, some rice, a piece of fruit. Whatever it was, where did its energy come from? If it was a plant, an apple, for instance, that's easy. The apple tree captured sunlight through photosynthesis, turning light, water, and air into the sugar that gives the apple its substance and sweetness. You are eating stored sunlight. But what if it was meat or fish? Well, what did that animal eat? It either ate plants or it ate other animals that ate plants. The energy is just being passed along the chain. The cow that becomes a steak ate grass, which was powered by the sun. The plankton at the bottom of the ocean's food web photosynthesize, just like plants on land. Every single calorie of energy that has ever fueled your body is a hand-me-down from the sun. Every step you take, every word you speak, is powered by the ghost of a sunbeam, captured by a leaf, maybe days ago, maybe years ago. It's an incredible thought, isn't it? That the energy to even have this thought is, at its root, solar. And it goes deeper. Take a deep breath right now. Feel your lungs fill. The oxygen you just inhaled, the gas that makes up about 21% of our atmosphere and is absolutely essential for our survival. Where did that come from? It is a waste product. It is the exhaust of billions of years of plant life and cyanobacteria, all using sunlight to split water molecules. Our atmosphere, Our breathable air wasn't just a given. It was built, layer by layer, breath by breath, by life harnessing the power of the sun. The sun didn't just give us food, it terraformed our entire planet for us. So, the food we eat is stored sunlight. The air we breathe is a consequence of sunlight. What about the world we've built? The fuel in our cars, the power in our electrical grid? For the most part, that's sunlight too. Just a much, much older vintage. Fossil fuels, the coal, oil, and natural gas that powered our industrial revolution and still run much of our modern world, are nothing more than ancient biomass. They are the compressed remains of prehistoric forests and vast oceans of plankton. They are, quite literally, Jurassic sunlight, buried and concentrated over millions of years. When you turn on a light switch powered by a coal-fired plant, you are releasing energy that last saw the Earth's surface when dinosaurs walked it. You are completing a transaction that began hundreds of millions of years ago. Every single part of our existence is tied to this cosmic bank account. The sun is the only one making deposits. Life on Earth is simply the system that has evolved to spend that energy. This is the central analogy that helps it all click into place. Life on Earth is like a vast and complicated financial trust fund, and the sun is the only one making deposits. When the deposits stop, the account inevitably runs dry. And that's the key. The sun's disappearance isn't an act of malice. It's not a punishment. It's not karma or cosmic justice. It is simply the end of the deposits. The universe isn't angry with us. It's just following its own rules of accounting. It's a simple, brutal equation. For billions of years, the energy coming into the Earth system from the sun has been immense. The planet absorbs this energy, and it also radiates energy away into the cold of space. As long as the input is there, a balance is maintained, a balance that we call a habitable climate. But when the sun vanishes, the input side of the equation suddenly becomes zero. The output, however, continues. The Earth keeps radiating its heat away, bleeding its warmth into the void. The energy that was given is now taken away. Or more accurately, the energy that was given is no longer being resupplied. It's a one-way transaction now. The balance is broken, and the account slowly, but inevitably, drains to zero. You see, it's easy to think of ourselves as separate from the cosmos. We live our lives down here on the surface, concerned with our own immediate problems, our own joys and fears. We see the sun as a lamp in the sky, a convenience that gives us light and warmth. But that's a profound illusion. We are not just living wondering the sun. We are living because of it, in the most direct and intimate way imaginable. Let's trace the chain of cause and effect one last time, from the impossibly large to the impossibly small, to the very core of your own consciousness. Deep in the heart of the sun, 93 million miles away, under unimaginable pressure, and at temperatures of 15 million degrees Celsius, hydrogen atoms are forced together. They fuse to become helium. In this process, a tiny amount of mass is converted into a colossal amount of energy, in accordance with Einstein's famous equation, $E=mc². A particle of that energy, a photon, is born. This photon begins a journey. It might spend 100,000 years just getting from the sun's core to its surface, bouncing around inside the dense star. But then, it's free. It flies through the vacuum of space at the ultimate cosmic speed limit. For 8.5 minutes, it travels, an invisible messenger carrying a tiny parcel of nuclear energy. Its journey ends when it strikes the leaf of a tree in your backyard, or perhaps a blade of grass in a distant field. That tree's chlorophyll molecule, a tiny, elegant machine perfected by billions of years of evolution, catches the photon. Its energy is used to power a chemical reaction, building a molecule of sugar. That's it. The photon's long journey is over. Its energy is now locked away in a chemical bond. Weeks later, that sugar might be in a piece of fruit that you eat. Your body digests it, breaking those bonds and releasing that stored solar energy. The energy is transported through your bloodstream to a neuron in your brain. And that tiny jolt of power, which began as a nuclear reaction in the heart of a star, helps fire that neuron, contributing to a cascade of electrical signals that becomes a thought, a memory, an idea. This very realization. The chain is complete. From a star's nuclear furnace to a thought in a human mind. That is the true depth of our connection. That is the cosmic receipt. It's a chain of causality that stretches across space and time, binding the internal world of our own minds to the engine of the solar system. So when we imagine the sun vanishing, we aren't just imagining the lights going out. We're not just talking about the cold. We are imagining the severing of that chain, right at its source. We're not just an effect whose cause has been removed. We, Amari, the cause, transform. We are the sun's energy, arranged into a complex pattern that is capable of looking back at the sun and wondering about it. This whole thought experiment, this dark, what if, it reveals a profound truth. Our existence is conditional. It's a gift. A constant, uninterrupted flow of energy from a star that just happens to be the right distance, the right size, and the right age. We are the result of a cause, the beneficiaries of a cosmic trust fund that has never missed a payment. To lose the sun, then, is to be fundamentally untethered. It's to have our origin story, our energy source, and our physical anchor in the universe all removed at once. It turns our home from a planet, a member of a stable family, into something else entirely. Something colder and much, much more alone. It turns our home from a planet, a member of a stable family, into something else entirely. Something colder and much, much more alone. With the sun gone, Earth is given a new and deeply lonely classification. It becomes a rogue planet, an orphan planet. And this isn't just a poetic term we've invented for our thought experiment. It is a real astronomical concept. Our galaxy, the Milky Way, isn't just filled with stars and the planets that faithfully circle them. Astronomers are becoming increasingly certain that it is also home to a vast number of nomadic worlds, planets that belong to no solar system at all. These are the rogues, the orphans, wandering the interstellar darkness alone. Some were likely born that way, formed in the cold of deep space without a parent star to call their own. But many, perhaps most, are thought to be exiles. They were likely formed in a normal solar system just like ours, but were kicked out through some chaotic gravitational interaction billions of years ago. A close pass by a giant planet, or a rival star, could have acted like a cosmic slingshot, flinging them out of their family and into the void. Scientists cannot be sure how many there are because they are incredibly difficult to see. They do not glow, and there's no nearby sun to light them up. But based on the few we've found, the estimates are staggering. There could be billions, perhaps even trillions, of these lonely worlds drifting through our galaxy. More orphans than there are stars in the sky. And in our scenario, we would join their number. Earth would cease to be the third planet from the sun. It would just be Earth. A wanderer. A ghost ship carrying the frozen memory of a civilization, sailing an endless, dark ocean. There's a deep, philosophical shift that comes with this. For all of human history, we've defined ourselves by our relationship to the sun. It is our anchor, our center, our reference point for everything. To lose it is to lose our address in the universe. It's like a child who has only ever known their own quiet, well-lit suburban house, suddenly finding themselves teleported to the middle of a vast, dark, and unknown city. The entire concept of home has been erased. You know, this whole event, this horrifying disappearance, would be the final, brutal confirmation of an idea that we humans have been wrestling with for centuries. It is called the Copernican principle, or sometimes the principle of mediocrity. And it sounds a little insulting, but it is one of the most important ideas in all of science. It started, of course, with Nicolaus Copernicus back in the 16th century. For thousands of years before him, we believed, we knew, that the Earth was the center of everything. The sun, the moon, the planets, the stars, they all revolved around us. It was a beautiful, comforting thought. It made us special. We were the protagonists of the cosmic story. Then Copernicus came along and suggested that, actually, we revolve around the sun. It was a monumental demotion. Suddenly, we weren't the center of the universe anymore. We were just another planet, one of several, circling a star. And over the centuries since, science has delivered one demotion after another. We learned our sun is just one of hundreds of billions of stars in our galaxy, and a fairly average one at that. We learned our galaxy is just one of hundreds of billions of galaxies in the observable universe. The Copernican principle is the summary of all those demotions. It is the idea that there is nothing special or privileged about our position in the cosmos. We do not live in a special place, at a special time. We are not at the center of the action. We are just here, in the cosmic equivalent of a quiet, unremarkable suburb. The vanishing of the sun would be the universe's ultimate lesson in this principle. It would prove, with terrifying finality, that our existence isn't a right. It is not a guarantee. It is a condition, a temporary state of affairs entirely dependent on our proximity to a stable star. We are not special because the universe chose us. We are special only because for a few billion years we've been lucky. Lucky to be in the right orbit, around the right kind of star. The disappearance of that star doesn't break a promise from the cosmos, because no promise was ever made. It simply ends our lucky streak. There's something profoundly humbling in that, isn't there? We build our civilizations, we write our philosophies, we create our art, all with this deep, unspoken assumption that the ground beneath our feet is solid and the sky above is predictable. We see ourselves as agents of our own destiny. But this event would strip all of that away. It would show us that we are, and always have been, utterly and completely, at the mercy of celestial mechanics that are far beyond our control. We are not the masters of our planet, we are its passengers. And our planet, in turn, is a passenger on a journey dictated by its star. When the star vanishes, our journey doesn't end. It just loses all direction. So where would we go? Flung from our orbit, we would travel in a straight line relative to our old path, moving at about 30 kilometers per second, or over 100 kilometers per hour. That sounds incredibly fast, but space is vast, beyond our ability to truly comprehend. Even at that speed, it would take us about 43 years just to reach the location of the next nearest star, Proxima Centauri. Of course, Proxima Centauri is moving too, so we wouldn't actually meet it. We just pass through the space where it used to be, long after it had moved on. Our journey as an orphan planet would be one of profound isolation. For thousands upon thousands of years, the view from our frozen world would be almost unchanging. The familiar constellations, the patterns we've told stories about for all of history, would slowly, imperceptibly distort as we moved away from our old neighborhood. Stars that once looked close together would drift apart, while others would move closer. After 100,000 years, the night sky would be almost unrecognizable. But one feature would remain. The Milky Way. Without a sun to wash out the sky, and eventually, without an atmosphere to scatter light, the great river of stars that is our galaxy would be a permanent, breathtaking fixture in the blackness. For any deep Earth survivors who might build an observatory on the frozen surface, it would be a sight of unimaginable clarity and terrifying beauty. They would watch nebulae drift by over millennia, vast, colorful clouds of gas and dust, where new stars are being born. These would be the only flickers of light and warmth in our long journey through the dark. We might, after millions of years, pass through one of these stellar nurseries. For a few thousand years, our frozen world would be bathed in the faint ethereal glow of newborn stars before we passed out the other side and back into the deep dark. It's a strange thought. The great tragedy of losing our sun would give us a view of the wider universe that no one in our time has ever had. A perfectly clear, unobstructed window into the cosmos. A beautiful consolation prize for a world that has lost everything. This entire scenario forces us to confront the most fundamental truth of our existence. Everything we are, everything we've ever done, is a product of a delicate and temporary stability. Think about it. Every decision you've ever made, every plan you've ever laid out, was made with the silent, unconscious assumption that the sun would rise tomorrow. The farmer who plants a seed does so with the faith that the sun will be there to make it grow. The company that builds a skyscraper does so with the faith that there will be days and nights, a world in which people will come and go from that building. Our economies, our cultures, our religions, our very biology, it is all built on the foundation of a predictable star. The vanishing of the sun doesn't just make the planet cold and dark. It pulls the foundation out from under the entire human project. It reveals that everything we consider permanent, our nations, our history, our knowledge, is written on a piece of paper resting on the edge of a bonfire. We just got so used to the warmth that we forgot about the flames. This is the ultimate lesson in humility. We have no control. That's the simple, powerful, and deeply unsettling message. We can build rockets, we can understand the laws of physics, we can even leave our own world for a short time. But we are fundamentally, and will perhaps always be, subject to the whims of the giant nuclear furnace we happen to orbit. Our home, our history, and our future all depend on something we have absolutely no control over. It doesn't care about our hopes or our fears. It doesn't even know we exist. Its stability is a gift, not a promise. And in this story, that gift is taken away. The solar system is a quiet, well-lit home. We know our way around. We know where the furniture is. We know when the lights will be on. Losing the sun is like having the walls and roof of that house instantly evaporate, leaving us sitting on a single chair in the middle of a dark, cold, and infinite wilderness. We would be a rogue planet. An orphan. A testament to the fact that in the grand scheme of the cosmos, we are not special. We are simply lucky. And our luck just ran out. It is a sobering realization that forces us to look at our own sunlit world in a completely different way. It makes you wonder just how much of the sun's light is secretly woven into the very fabric of our modern lives, in ways we've never even considered. It is a sobering realization that forces us to look at our own sunlit world in a completely different way. It makes you wonder just how much of the sun's light is secretly woven into the very fabric of our modern lives, in ways we've never even considered. This thought experiment, this dark hypothetical, acts as a kind of unlit mirror. When we hold it up to our civilization, the reflection that comes back is strange. We see our world, but with one key element removed. And in doing so, we suddenly see all the things that were only there because of the light. It turns out that almost everything we call normal, everything we consider a part of modern life, isn't really a product of human ingenuity alone. It is a collaboration, a partnership between us and our star. Let's start with the most fundamental part of our modern world: energy. The power that keeps the lights on, that moves our cars, that runs the internet. It feels like something we created, something we harness from the earth. But that's only half the story. In reality, our entire energy infrastructure is little more than a complex system for collecting and repurposing sunlight. The most obvious example, of course, is solar power. We see those panels on rooftops and in vast desert arrays, directly converting photons that have traveled 93 million miles into the electricity that charges our phones. That connection is direct and beautiful. But it's just the tip of the iceberg. What about wind power? A wind turbine is also, in a way, a solar-powered device. Wind is created by differences in air pressure, which are caused by the uneven heating of the planet's surface. And what does the heating? The sun. Without the sun's constant energy warming the equator more than the poles, the atmosphere would become still and stagnant. The great winds that sweep across the continents would die down, and the turbines would cease to turn. But the deepest connection, the one that truly powers our world, is far older. It is the energy we get from fossil fuels, from coal, oil, and natural gas. We think of this as a geological resource, something we dig up from the dark. But what are we really digging up? We are digging up sunlight. Ancient, buried sunlight. Think about it for a moment. Hundreds of millions of years ago, during the Carboniferous period, the Earth was covered in vast, lush forests and swamps. Countless trillions of plants and tiny marine organisms spent their lives doing what plants do. They captured the energy of the sun and converted it into organic matter. They were, in essence, tiny biological batteries, storing solar energy in their leaves, stems, and bodies. When they died, they sank to the bottom of swamps or oceans. Over millions of years, they were buried under layers of sediment, compressed by immense heat and pressure, and their stored solar energy became concentrated into the substances we now call fossil fuel. So when you fill your car with gasoline, you are pumping in the liquid remains of ancient organisms that were powered by a sun that shone long before the dinosaurs. When you turn on a light switch powered by a coal-fired plant, the electricity zinging through the wires is the released energy of sunlight captured by a fern 300 million years ago. Our entire industrial revolution, the whole towering edifice of modern society, was built by burning the ghosts of ancient sunshine. Every factory, every skyscraper, every single journey we take, it is all a delayed reaction to photons that landed on Earth eons ago. We are, in a very real sense, running our present on the solar energy of the distant past. And in a world where the sun vanished, that connection would become painfully clear. We'd have our reserves, of course. We could keep digging up that buried sunlight for a while. But it would be a finite resource with no hope of replenishment. We would be living off a solar inheritance, an account with no more deposits ever being made. We'd be drawing down the last remnants of a light that was already gone. This solar rhythm isn't just embedded in our fuel, it is written into the very structure of our days, into the way we organize our life. Consider the standard workday, the classic 9 to 5. It feels like a modern invention, a product of corporate culture. But its roots are far older and are tied directly to the sun. For almost all of human history, significant work was only possible when the sun was up. Daylight was the ultimate resource. You farmed during the day, you built during the day, you traveled during the day. When the sun went down, the world became difficult and dangerous. Productive life largely stopped. Our entire concept of a day of work was defined by the arc of the sun across the sky. Phrases we still use, like making hay while the sun shines, are direct echoes of this reality. It meant you had a limited window of opportunity to get essential things done, and that window was defined by sunlight. Even after the invention of artificial lighting, candles, gas lamps, and eventually the electric bulb, this ancient pattern persisted. We had the technology to work around the clock, but the cultural habit was already set. The 9 to 5 is a relic, a kind of social muscle memory, from a time when our lives were fundamentally governed by the availability of natural light. In a world without a sun, this entire structure would become meaningless. With perpetual, unchanging darkness outside, why would we start work at 9 in the morning? What would morning even mean? We could organize our schedules however we wanted, perhaps in shifts that keep a subterranean city running 24 hours a day. But that shared, universal pulse of a planet, waking up with the dawn and settling down with the dusk, would be gone. We would lose the single greatest timekeeper we've ever known, the one that synchronized billions of lives into a single, familiar rhythm. Our entire social clock is a solar clock. We just forgot that we were looking at the sun to tell the time. And this solar dependency extends beyond our energy and our schedules. It underpins the very structure of our globalized world. Think about the food you eat. The fact that you can walk into a supermarket in, say, Chicago in the middle of a blizzard and buy fresh strawberries from Chile or green beans from Kenya is a modern miracle. We see it as a miracle of logistics, of shipping and supply chains. And it is. But it's also a miracle made possible by the sun. The only reason we have year-round access to fresh food is because it is always summer on X somewhere. Earth's axial tilt, the very thing that gives us our seasons, means that while one hemisphere is cold and dark, the other is tilted toward the sun, bathed in the light and warmth needed for agriculture. Our global trade network is in many ways a system for shuffling sunlight around the planet in the form of food. We grow crops where the sun is shining, then ship them to places where it isn't. If the sun vanished, this entire system would break down instantly. It wouldn't be a slow decline. It would be an immediate, catastrophic failure. There would be no somewhere else to get food from. Every corner of the planet would be plunged into the same winter at the same time. The concept of a growing season would become a historical footnote. The globalized web of trade that we rely on for our very survival is built on the simple, reliable fact that the sun will always be shining on the other side of the world. Take that away, and the threads that connect us all just unravel. And so, as we hold up this unlit mirror, the reflection becomes clearer and clearer. Our modern life is not a fortress of technology we built to insulate ourselves from nature. It is a delicate and intricate sandcastle, built on the shore of a cosmic ocean. It is impressive, it is complex, but it only exists because the tide, the sun, is predictable and constant. Its light provides the energy, its rhythm provides the structure for our days, and its reliable presence across the globe provides the foundation for our interconnected world. By imagining a world without it, we do not just see the darkness and the cold. We see the profound and intricate ways the sun's light is reflected in everything we do and everything we are. It's in the electricity in our walls, the food on our tables, and the very concept of the time on our clocks. We live in a world that wasn't just built on Earth, but was built by the sun. If this is the civilization the sun built, what kind of stories, what kind of myths would we tell our children about it generations later in the endless dark? If this is the civilization the sun built, what kind of stories, what kind of myths would we tell our children about it generations later in the endless dark? Let's take one last journey in our thought experiment. Not down into the Earth's core, but forward. Far, far forward in time. Let's imagine that we did it. Against all the odds, humanity survived. Great migration into the deep, powered by geothermal heat and nuclear fission, was a success. The technical challenges were overcome, and a new way of life began in the warm heart of our now rogue planet. Centuries pass. Then, millennia. Generations are born, and live their entire lives in vast, cavernous cities, miles beneath the frozen surface. For them, this isn't a temporary shelter. It is just home. The constant, gentle hum of geothermal turbines is the only weather they've ever known. The rock ceiling, crisscrossed with pipes and lights, is their only sky. Their world is one of metal, stone, and the steady, predictable glow of artificial lamps that mimic a rhythm no one alive can truly remember. For these descendants, the world we know, the surface world, is a history lesson. It's a half-believed legend. And the sun is a myth. Think about how we view ancient Rome. We know it was real. We can see its ruins, read its texts. We understand its foundational importance to our own world. But can you truly, deeply imagine what it was like to walk its streets? To feel the specific heat of an Italian afternoon? To hear the clamor of the Forum? For most of us, it's not a memory, it is a story. A powerful one, but a story nonetheless. For the last generation of humanity, this is what the sun would be. It would be their Rome, their Atlantis, their Garden of Eden, all rolled into one. It wouldn't be a star, a ball of hydrogen and helium undergoing nuclear fusion. That scientific language would be ancient history, found in brittle digital archives. To the common person, the sun would be a character in a story, a god from a lost paradise. Priests or storytellers would gather the children under the glow of a particularly bright lamp and tell them the old tales. Before the Great Cold, they would begin. Humanity lived in a place called the Above. And in the Above was ruled by a creature of impossible light and warmth. They called it the sun, Neunand. In these stories, the sun wasn't an object, it was a being. It had a personality. It was a giver of life, a painter of the world. It would rise each morning to banish the monsters of the dark, and it would rest each evening. The stories would describe a feeling that no one could actually feel anymore. Warmth on your skin from something impossibly far away. Imagine trying to explain that. It would be like trying to describe a sixth sense. The children would listen, their eyes wide in the electric light, trying to picture a fire so large it could warm an entire world, a lamp so bright it could create a ceiling of pure, endless blue. It would be magic. It would be the greatest of all fairy tales. And what about those colors? Blue, dot, grantine. These words might still exist, but they would have lost their connection to reality. They would be mythical concepts, words freighted with a deep ancestral nostalgia for something no one has ever experienced. A teacher might pull up an ancient text, what we would call a book or a video file, and show the children a picture of a forest. This, the teacher would say, pointing to the leaves, is green. Nah. It was the color of life, the color of things that grew by eating light from the sun. Neunen, ancients. The children would nod, but they wouldn't truly understand. Their food comes from chemotrophic vats and sprawling fungus farms, all pale whites and earthy browns. Green would be an intellectual idea, not a sensation. It would be a holy color, a color from the time of the gods. And then the teacher would point to the sky in the picture. And this, they'd say, their voice hushed with a kind of reverence, this is blue. Nami. It was the color of the above when the sun was awake. The stories say it was the color of peace, of infinite space. Nanai, one. How could they possibly comprehend it? Their sky is raw. Their space is the distance between one cavern and the next. Blue would be a word from poetry, a symbol for everything they've lost. It might be the color they associate with sadness or longing, a profound, unquenchable melancholy passed down through generations, a longing for a home they never knew. Their entire culture would be a reflection of this endless, starless night. Their art would likely value texture over color. Sculpture and intricate carving would flourish. Music would be incredibly important. Sound, echoing in the vast subterranean spaces, would be one of the main ways they experienced beauty and grandeur. Their songs would be haunting ballads of the sunken world, the paradise of the above that was lost to the endless winter. Their stories, their myths, would all revolve around two core ideas. The first would be a cautionary tale, a deep respect, and perhaps even a fear of the surface. The Great Cold would be the ultimate villain in their folklore, a relentless monster waiting just above their heads. Expeditions to the surface, if they ever happened, would be the stuff of heroic legend, like journeys to the underworld. But the second, and more powerful, idea would be hope. Because humanity, even in the deepest dark, needs something to look forward to. It needs a dream. Their dream would be pointed outwards. Their best minds, their engineers and physicists, wouldn't be focused on maintaining the geothermal plants anymore. That would be solved. Their grand unifying project would be to leave. To build a ship that could break through the miles of ice, leave their frozen orphan planet behind, and make a generations-long journey through the dark to find a new star. The sun, the one they lost, would be a memory, a myth. But the idea of a sun, any sun, would become the central driving force of their civilization. Their astronomers wouldn't be looking for planets, they'd be looking for suns. G-type main sequence stars, stable and warm, would become the promised land. The children, after hearing the stories of the lost sun, would look at the star charts projected on the cavern walls. They wouldn't see distant points of light, they'd see destinations. They'd see a chance to reclaim the myth. A chance to feel real warmth, to see blue with their own eyes. It is a bittersweet thought, isn't it? A humanity that survives by turning its greatest loss into its most powerful legend. A people for whom our everyday reality, a blue sky, a green leaf, the warmth of a summer afternoon, has become the stuff of epic myth, the ultimate, perhaps unattainable prize. They would be a testament to our resilience, our incredible ability to adapt. But they would also be a monument to what was lost. Their culture would be a story told in the dark, a story of a light they could only imagine. And their greatest hope would be to one day find their way out of the story and back into the sunshine. It's a look at how culture and memory and hope can endure, becoming the tools we use to survive even in the most extreme, the most impossible of circumstances. The sun would be gone, but the story of the sun, the idea of it, might just be the one thing that saves everyone. The sun would be gone, but the story of the sun, the idea of it, might just be the one thing that saves everyone. And that brings us to the end of our journey. It might feel like a strange place to finish, talking about stories and myths after traveling through the hard physics of a frozen world. But it leads us to the most important question of all. Why do we even do this? Why do we put ourselves through a thought experiment that's so fundamentally terrifying? Why imagine the single worst thing that could ever happen to our world? It's a fair question. This entire exercise, this journey into the cold and the dark, can feel a little bit morbid. Like we're indulging a strange, cosmic horror story for no reason. But I promise you, that's not what this is about. It's not about a fascination with the end of the world. In fact, it is the complete opposite. It's about a fascination with the world as it is, right now. Think of it like this. You don't really think about the air you're breathing, do you? It's just there. It's constant. It's automatic. But if you hold your breath for 30 seconds, what's the only thing you can think about? That next, glorious lungful of air. In that moment, the simple act of breathing becomes the most beautiful, most important thing in the universe. What we've just done, for this entire documentary, is hold our collective breath. We've willingly plunged ourselves into a world without its air, without its warmth, without its light, for one simple reason: to finally, truly appreciate what it feels like to breathe. To understand what we have by imagining, for just a little while, what it would be like to lose it. These grand cosmic what-ifs, they're not predictions. They're not warnings. They are exercises in gratitude. They are tools for seeing. By mentally taking away the biggest constant in all of human history, we are forced to see the profound and staggering beauty of our everyday reality. We're forced to notice the things that are so foundational, so ever-present, that they've become completely invisible to us. The simple, steady warmth of the sun on your face on a cool day. Have you ever really stopped to think about that? It's not just a nice feeling. It's the energy of a nuclear furnace, 93 million miles away, crossing the vast, frozen emptiness of space, and ending its journey as a gentle sensation on your skin. It's a physical connection to the heart of our solar system. We are literally touched by a star every single day. And what about the rhythm of it all? The slow, predictable, and utterly reliable cycle of day and night. It's the planet's own heartbeat. It's the clock that has governed all life for billions of years. It tells the flowers when to open, the birds when to sing, and our own bodies when to rest. We set our lives to this rhythm without a second thought, trusting, with a faith deeper than any other, that the sun will rise in the morning. We just expect it. This whole thought experiment is designed to shatter that expectation, just for a moment, so that we can look at our world not as something that is owed to us, but as the incredible, fragile, and magnificent gift that it truly is. So you see, our journey into the dark wasn't really about the darkness at all. It was all about the light. It was about finding a new way to see the things we look at every day. The outline for this entire scenario we've explored is a bit like a fire drill. The point of a fire drill isn't to make you obsessed with fire. It is not to make you live in constant fear of smoke and flames. The point is to practice the motions, to understand the plan, so that you can go back to your work feeling safer, more prepared, and more appreciative of the calm, quiet, normal state of affairs. The drill is a scary story you tell yourself, so you can better appreciate the reality of your safety. And that's what this has been. A cosmic fire drill. We've walked through the imaginary catastrophe. We've seen the world freeze, and the stars blaze in an endless night, and we've imagined humanity huddled deep within the earth. And now, we get to come back. We get to open our eyes and realize it was just a story. The sun is still there. The warmth is still there. The world is still turning. The fire isn't real. And that feeling of relief, that sudden, quiet wave of gratitude, that's the whole point. By taking the sun away, just in our minds, we suddenly see its fingerprints everywhere. It's not just in the sky. It's on your plate. Every apple, every grain of wheat, every leaf of spinach is just a little piece of captured sunlight, converted by photosynthesis into the energy that fuels your body. The entire food web of our planet is a story written by the sun. It's in the gasoline in your car. That's just ancient sunlight, captured by prehistoric plants and algae, buried and compressed for millions of years into a liquid battery. When you drive to work, you are running on the energy of a sun that shone on the dinosaurs. It's in the oxygen we just talked about. The very air that fills your lungs is a byproduct of life that is powered by the sun. Every breath you take is a gift from the star we orbit. Our journey wasn't about the what if. The value of this story isn't in the terrifying details of a rogue planet. The real value is in how it illuminates the what is. The beauty of what is. It holds up a mirror to our world, but by showing us the reflection in total darkness, it allows us to appreciate the light that creates the image in the first place. It is a lesson in perspective. It's so easy for us to feel like the center of everything, to get lost in our own small human-sized problems. But then you contemplate the source of all our life and energy just vanishing. And you're instantly reminded of the scale of things. You're reminded that we live on a small rocky world, utterly dependent on a star that we have absolutely no control over. And that realization, that feeling of cosmic humility, isn't meant to be frightening. It's meant to be clarifying. It reminds us that our existence here is not a given. It's a privilege. It's the result of a 1,000,000,000 cosmic lottery win. We happen to live on a planet in the perfect spot, orbiting a stable, long-lived star. And just taking a moment to recognize that improbable fact is an act of awareness. It is an act of seeing where we truly are. So, the enduring appeal of this dark question isn't a mystery. It's the same reason we tell ghost stories around a campfire. The imagined monster in the woods makes us appreciate the warmth and the safety of the fire. The story of the darkness makes the light feel more precious. By exploring the ultimate loss, we learn to better appreciate what we have. We've talked about physics and mythology, about geology and psychology. We've imagined the end of everything we've ever known. And now, we're back. We've held our breath, and it's time to exhale. It's time to take that first, conscious, appreciative breath. The story is over. And our world is still here. The sun is still 93 million miles away, fusing hydrogen into helium, bathing our planet in the energy that makes everything you see and everything you are possible. The great cosmic clock is still ticking. The planet's heart. So, I want to leave you with one final thought. One simple invitation. The next time you have a chance, I want you to do something. Go outside and just notice. Notice the blue of the sky, a color that only exists because sunlight is scattering through our atmosphere. Notice the sharp, clean edge of a shadow on the ground, a perfect silhouette drawn by a distant star. Notice the warmth on your skin, and remember the impossible journey those photons took just to greet you. And if you can, try to watch the next sunrise. Don't just see it. Watch it. See the color returning to the world. Feel the first hint of warmth. And recognize it for what it is, the single most reliable and profound miracle in our world. A daily promise, kept for 4.5 billion years, that the long night is over. Because the ultimate truth of this entire thought experiment, the one great lesson learned from imagining the end of it all, is breathtakingly simple. By exploring the ultimate darkness, we learn to better appreciate the light.